Okay, I think we have a hardcore networking crowd, but we can't wait. So in the paucity of time, we will start. Assalamu alaikum. Welcome to this 140th edition of the Zak World of Façade conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I just quickly want to introduce the event to you before we start today's proceedings. Right. Okay, so just to give you a brief about the Zak World of Façade conference series, we started this back in 2012. We finished around 139 editions in 39 countries around the globe. This is edition 140. This is our fourth edition in Riyadh, 2017, 2019, 2022, and now 2024. We've been doing these events all across the globe, right from New Zealand up until Canada. This is our event calendar for next year. This is our last event of the year, finally. We've had 35 events this year in 26 countries, so it's been a long journey from January until now. But I think we are in the most exciting country in the world for construction right now. There's a lot happening in Saudi Arabia. So we have speakers from different parts of the region and other parts talking on their experience on designing, engineering, and executing facades. So I hope you'll enjoy today's event. But before we get into the program, I'd like to quickly thank our event partners without whom this wouldn't have been possible. Starting with Shuko. So Shuko is a world leader in aluminum door, window, curtain wall systems. They are ever present here in the Middle East region and have executed some iconic projects. Our associate partner, starting with Axalta. So Axalta are into liquid and powder coating solutions. They have a wide range of solutions for steel, for aluminum and other profiles. Cosentino is a Spanish company. They've got an interesting cladding product called Decton, which can be used on facades. Next partner is Cox Gomel Group, Alimac Group, which is their parent company, Cox Gomel, Mantec, and their local partner here in Saudi Arabia, Masa. So they are into facade access and facade cleaning solutions. So maintaining your facades are important, and they are world leaders in what they do, specialists in high-rise buildings. Dow is one of the leading manufacturers of high-performance sealing and bonding solutions. Ephesus is a Portuguese company. They've got weatherproofing solutions, vapor barriers, moisture control, air barriers, and other value-added products. Equitone has fiber cement cladding. So cement board cladding with a lot of different decorative finishes is now back in fashion, and Equitone are one of the companies leading the way. Euramax are into aluminum coil coating. They are a Belgian company, and they've got some interesting solutions for coil coating and finishes. Fischer, again, is a German company. They've got a lot of innovative solutions. They've got pacifier protection, fixing solutions, ventilated cladding, and many more. Flexbrick is a Spanish company. They've got an interesting fixing system for cladding and in a brick format, so which is very, very interesting and unique. Foster is a Swiss company, now part of the Rainers Group. They have systems for fire rated in steel and for fire rated profiles in steel. Hilti, again, needs no introduction, one of the leading companies in high-performance tools, pacifier protection, anchors, fixings, many more products. Curare is the mother company of the laminated glasses, interlayer brands, Throsifol and Sentry Glass. Protec Group, which has their brand Alwan, is again a leading powder coating company here out of the Kingdom of Saudi Arabia. Pyrobel is the fire-resistant glass from the AGC Group. Serge Ferrari, a French company. They've got fabrics which can be used in envelopes and also now in facades. Siderice, along with their local partner Physico here in Saudi Arabia, are a pacifier protection company. They've got products for cavity barriers and perimeter edge protection, slab protection. Swiss Pearl, another fiber cement company from Switzerland, obviously, with the name. Again, fiber cement board is picking up, becoming back in fashion. A lot of new finishes, a lot of possibilities, can be recyclable also. So fiber cement board is one of the more viable options now as a cladding material. Thomas Bellwright, Saudi Arabia. So Thomas Bellwright, one of the leading testing labs in the region, based out of the United Arab Emirates. They have now set up a Saudi Arabian branch, so they would be doing facade performance testing here in Saudi Arabia. Vector Foil Tech, German company, they're into ETFE solutions, which is a alternative, let's say, to glass for building envelopes and for cladding for large span and lightweight structures. These are our associate partners. All of them have a booth. Of course, I don't need to tell you to network with them. All of them are looking forward to seeing you, but please do. We've got around 21 booths here, so have a look around and you'll find some interesting products for your projects. Our next one in the region is in Dubai, which is our first time doing a 2-day event, 23-24 April at the Coca-Cola Arena. And trying something different and unique over there. Still lots of unknowns, but let's see. Eventually, we'll get through there. This is on the 23rd and 24th of April at the Coca-Cola Arena in Dubai. Just to summarize my talk, my last slide is on our events for next year. We've obviously got Istanbul, a little bit extended region. We've got Riyadh. We are hoping to do our first 2-day event in Neom if we get the permission later next year. And of course, we've got Dubai in the schedule. So this is what we have in schedule for the Middle Eastern region for 2024. Few things we will be recording today's event. So those speakers who have allowed us presentation to share their talks with you, we will give you a YouTube link and you can watch the recording of today's event. Those who have the delegate lanyard, you will have a USB stick on your lanyard. That USB has the brochure of all our 22 sponsors, 21 sponsors over here. You can use them for contacting them and things like that. So that's it from me. We'll get straight into the agenda. We're already running late. I'd like to call upon Ms. Salwa Al-Sabbagh from Dar Al Omran. She's going to be our event host and she'll be taking you through until the end of the day. Thank you very much.
Good morning, everyone. Assalamu alaikum, and welcome all to the Zak International Conference on World of Façades. I think we are a good crowd today of engineers, consultants, I think manufacturers, developers, and all of you esteemed guests, thank you for coming today. So, without further delay, let me ask, I asked myself, why facades are so important? Why are they so important for us in our architectural, urban, city life? Well, if we look at it from a non-architectural point of view, it's an expression of the building, it's an expression of the identity, it's a reflection on the challenge, and it allows us to understand what is behind that hidden skill, although we're not, professionals in that term. For the architects and engineers and structural civil engineers, it's about a music scale that the designer actually arranges the notes of it. And if there is any missing note in that music scale, there will be distortion. So we try and avoid these distortions to happen. And we join our efforts so that the facade in its functional, aesthetic, and a structural system actually convey the full message of that beautiful music and embellish our cities. With the growing technologies, we can see, and with globalism, it was very easy to import any facade that we see in Europe to the Middle East, or that we can import from the Middle East to other places in the world. However, here comes the question of the original role of a facade is to respond to its environmental and sociocultural aspects of the building and the context itself. So here, today, we try to answer these questions with all of our esteemed speakers about how our new innovative technologies, our new designs, and our new intervention and materiality could help achieve sustainability to respond to the harsh environmental conditions, and to achieve identity, to remain authentic to the context where we are in, and to provide contemporary and innovative solutions at the same time. So without further delay, I would like to introduce our first speaker, Lars Anders, CEO of Priedemann Facade Experts. I think he has done a great job in Burj Khalifa project. And he is leading currently a team on facade planning and consulting with his degree in civil engineering. The floor is yours.
Thank you so much. A very good morning. Is it a pleasure or a pressure to be the first in the morning? It's a good question. I most probably have not to wake you up. Everybody looks very awake. It's a pleasure being here. I came yesterday and I'm in the region for more than 20 years. And it was a quite different arrival in Saudi this time on the airport. What is most probably the best news anyhow. Such a warm welcome and such an easy step into the country, and always open eyes and interested people around us are making us very optimistic that we jointly can run in the right direction. I would like to take you a little bit through our recipe for successful delivery of iconic buildings. In my long working in the facade industry, I came from a metal workshop of my father into a consultancy position, employee number 6 in Priedemann. We went through a lot of things and big dreams, and lots of projects changed during execution through so-called value engineering. And I would like to take you on a process where we believe we can maintain the fabulous ideas from the concept architects into real action. Short introduction, we are in certain locations in the world, 150 people now. Our location in the Middle East is in Dubai since 2005. Obviously, we work in Germany as consultants in the scale of Europe in challenging jobs, in the US and Americas, in Asia, and in the Middle East for longer. This is a big difference in our starting career. Being a consultant today, for us, started as contracted facade engineers for fabricators building challenges in the beginning. What was good for us to go through this learning curve. If you do in liability what is finally executed, you have a very interesting and good base to consult others later how to do it. Obvious in the Kingdom of Saudi Arabia, I would call it the first gold rush. We were part of whatever happened in King Abdullah Financial District, and most probably the majority of people being part of that have seen how great it is, but everybody knows we can do better. So how should we get prepared for going into design stages? We call it programming phase, planning the planning. And it sounds so simple to clarify with the client, what do we want to achieve? When should we deliver? And how much can we afford? It is an interesting experience, most probably for the majority of consultants, that you rarely get a budget. When these high-end concepts arise, it is always a statement, money doesn't matter, but money matters a lot in the end of the day. And designing into something where you don't know what you have to commercially achieve is the first trap you can step into. So when we come together to clarify what should be achieved, we should, for example, discuss the expected user comfort, because user comfort relates to the glazing we select, to the type of cooling you use inside your rooms. Is it driven air, or is it more a thermal activation of surfaces, putting heat or cold in radiation into the building? What do we want to achieve for those people using our projects later on? That need to get qualified to avoid that later, through wrong input, you are losing these targets in mind. It needs to go in a specification, we all know that, but finally you get better options and you might lose what you had in mind to do. Designing with life cycle understanding is what we can see in Saudi Arabia now. This is a big change to 20 years before. We want to build something what lasts long, and we want to build something where we do not just tear down the material we installed, that there is further use and all this implemented. We want sustainability in facades. These green images work perfectly in Singapore. It might be not the right approach for Europe, and it might be not the right approach for Saudi Arabia. But important is that this greenery is standing for comfort, it is standing for clean air, it reminds us of something, and these type of sustainable facades is what we owe our kids that need to get qualified. This is something you cannot negotiate about. Something which is not sustainable designed should not get built these days. It is not good for us and not good for the future. So this is something I would like to pinpoint on, that we qualify that. Solar power station building envelope, we did this project in Dubai, creating energy. Photovoltaic is one answer on what you can do with the building shell. It's a good answer. And it can be so expressive as shown here. It can be integrated into something. In Europe, for example, the current trend is that investors do not allow us to use the top of towers for photovoltaic installations anymore. There are the green gardens, there is the chill out area. They collect the highest rents on the top floor of a building. Nobody want to have solar there installed, or it is a shading system where under it you have your action going on. But in general spoken, these elements go into facade, and based on a totally different price tag today, I can tell you that integrated photovoltaics is performing well, and it doesn't cost so much more than a natural stone anymore. It reached a reasonable price level. So think about how and where we can put it. Not all of it need to be blue. It can be done in colors. It is very flexible. CO2 reduction is extremely important and difficult to grab for designers today. There's a lot to learn about, because we are used to build performance against money. Now people come around and tell you, well, a criteria is how much is the carbon footprint in that material, what might be more costly. You might pay more even for less performance. And that is something what doesn't click in investors' heads. But it is important. So we and all our fabulous colleagues in the industry work on tools to express to investors what is the additive value of reduced carbon footprint, what is the price tag on it, and why do we have to do that? That need to be expressed in specifications to guide people right on track. It can be not ignored, and it is extremely important for upcoming refurbishments. We have built in the Middle East enough things in the last 20 years we have to take down because they leak, they are ugly, they are overaged or whatever. And when we do so, we need to find a way to reduce the next carbon footprint by using a proportion of that material further, reglazing a stick system or whatever we're going to do. It's an important design aspect. Cradle to cradle is something we could talk about most probably for an hour, and we don't have the time on it. Just keep in mind the word. It is about cycle of materials and technologies. It's a biological cycle. It is something you have to talk about with your team, how you keep materials being used and technologies being introduced in that cycle for an efficient way in respect of the upcoming generation. Digitalization is not BIM, and it is not meant to make things cheaper or something. It's a coordination platform to bring things together. It is a digital twin of what we are going to build. It allows you to maintain your projects digital. You can financial plan in digital models. What is the cost impact in 5 years' time to add a shading or change a glazing or all that? Keep this in mind when you qualify what we are going to do in Saudi. BIM is such an empty wording in the market and not used to an extent how it could be used. We need to stay strong on that we have as built LOD 450 in hand finally to embed information to run our projects later based on that. When we do a digital twin for our clients in Germany, we can tell you the size and the weight of the glazing. And when we take it off in 5 years' time, we could at least instead recycle it, bring it to Africa and install it again and give it another 20 years of use where people have no glazing at all. For that, you need information. If information is available, an after-sales market is established, as for cars, and then cars go into the next hands. Our materials should be further used. For that, we need digital information. And for marketing purposes, you hunt those certificates. I would not say they are useless, they are important, but they don't add value. But it qualifies what you have in hand. If you have an appropriate platinum certificate, you can brand your project as sustainable. People like those colors, green and red. Nobody is buying a red fridge anymore. So we need to build green buildings. So you qualify those certificates from wherever country are you going to use it. In Germany, it's DGNB. Here, LEED, obviously, is very common. Create a project under a certificate that you can put it into comparison to your neighbors, that people renting your project, moving into your project, understand what is the build quality of that development. This is not rocket science. And don't ship what you want to build to Saudi. We really should put our fingers on doing things here. There is always a certain amount of technology you have to bring into a country, but the developments happening allow a real industrialization in Saudi Arabia of a local industry with local people, what makes this country proud in the end of the day, what they could achieve. Facade works is not rocket science. It is something where you have to do the right things in the right moment, and that you have to then you have to stay strong on education. You have to think about how you keep your labor and educate them instead of kicking them out after 2 years' time and canceling their visas. Then you can achieve quality when they are along with you and you develop what need to be developed. We need to do the upcoming things here. This is our message statement on our work. Anyhow, it's about knowledge transfer, and it is what all our famous and exciting colleagues want to introduce to the market as well. So if we did achieve something, we care. This is extremely important. When you build something, what is attractive and what people carry, then they take care of it. Some people wash their cars because they were saving money for a long time on it, and then they like it a lot after they bought it, and then they maintain it and keep it proper. And this is important for our projects. When we build under the first aspect, user comfort, projects people like, and when the building is not only an expression, when the building is creating outside the building a livable environment where people like to be, they will take care of their projects by nature. And then projects keep their quality, they get accepted, they are part of an interesting life, and everything goes in the right direction. So, successfully facades delivered stand for pre-qualifying what should be delivered, from where, when, and on which cost. I can recommend to the audience who is in charge of consultancy or architecture or anything, let's stay strong and stiff in front of our clients. No budget, no design. I can tell you that, because things go wrong. It is never built what should be built if the figures are not on the table. This is at least my experience. IPD, integrated project delivery, is something I want to introduce only short to you. Something new not being done before. It's not about IPD, it's about a project. I would not say copy and paste, but when we build repetitive, where we know what we build, we can qualify, specify, and put it into the market. When we do something new first time, and nobody knows how long it takes and how it will be done and all that, you need a different coming together. And I'm sure today, lots of presenters will talk to you about getting the right people early on the table, including the executing industry, including the main contractor, and all that. Integrated project delivery is a joint approach on the product we want to deliver. And when you do so, for example, the Festa Automation Center, I presented that longer back, but this was a client who wanted to build something new in Germany. It is difficult. A fully glazed building on our environmental aspects in Germany nearly don't work. But the client wanted to have it. So he formed early a team to get a facade being created where no extra shading was introduced. They had that idea about a diamond, and it should be cost efficient and all that. So with all the colleagues we had on board, we created a facade we call ACT facade, active cavity transition facade. It's a double skin facade, very simple, using the inner glare blind, a regular blind from Varema, what we use as a double skin facade. So when the blind is going down, it is creating a cavity on no additional cost. The blind is there anyhow, just by positioning where we take the air out, we take the incoming air through the facade is taking the upraised heat back into the system, and that creates a great comfort. The secret behind that is, it is not a better U value, it is a more comfortable surface. Some of you might have touched upheated insulated glazing in the past, how warm it gets on the inside. And when you cool a room on 18 degrees to feel 20, the reason is that all the surfaces have 20 degrees, but the facade have 38 degrees. So by being in that unbalanced situation, you need to cool the room down to 18.5 to feel 20. This costs money. With that facade approach, with the blind, cutting off the glazing when the sun comes around and an anti-glare system is required anyhow, you, like closing a curtain, you block that heat, you flow the air through that, and you achieve something what is saving tremendous money. This is explaining this system. And the interesting part of it is we are using this curtain wall now to refurbish a lot of wrong executed projects. By bringing the blind later into the system and adjusting on the airflow, we can use or establish a different comfort without increasing the need on cold air in the room, because we work on it proper. When you don't cool it on 18.5, you cool it on 20. The saving on airflow is massive. It is 30%. Based on this, you can avoid that you need a new HVC system when you want to upgrade comfort and performance. You remember that I spoke about user comfort. This is about user comfort. This is not additive invest. It is not a double skin facade. We built a mock-up on that, and this expresses how much space it's gonna save. The double skin facade is this deep. A closed cavity facade is this deep. A box type window is this deep. An ACT facade is a regular facade. You might save per running meter of your curtain wall 650 millimeter per meter. You can rent to your client, and you don't pay the double skin, and you save a lot of money. Consider in your considerations such a solution we can take you on with. It is based on science and computer simulations and all that, so it will work. Same project, different idea. Robotic cleaning was something the client wanted to be established. That takes time, but it was introduced, and I'm sure this is something what will be interesting for Saudi Arabia. I'm not even talking about the line. I mean, most probably we don't want to clean the silver shining glass on 170 kilometers with all these guys hanging on that surface. And this works already. It is done in Germany. The building is automatic cleaned with this little robot. He's not looking on your underwear in the morning by being in your hotel room, which is not very pleasant, honestly. It's not that colleague from wherever he came from. So this is something what you need to consider. And it is like your dishwasher. It is reducing water by 7 times because it cleans efficient. This is ecologically interesting. It hangs on the anyhow used BMU system. Introduce it. You need to bring the party on early when you want to establish these things. So, learning from history, being local present. Everybody is opening an office now in Saudi. We want to be here, but the majority of players are for a long time in the Middle East. Let it be there or there. You need to be part of this civilization, I think, to deliver into that world what is required into that world. It is nice to have that beautiful designs are created in New York or in London. I would take those designs. If I would be a client, I would never appoint a local consulting engineer from those markets as long as they are not here, as long as they don't have experience in this part of the world. You want to deliver here and install here. So a kind of design can be created, but a reliable execution need to depend on people understanding this part of the world. Local production is important. We need to collaborate to bring it on new standards. This is most probably not what we want to do, but it is a very respectable approach. These people were in Corona still available, right? Where people could not import from China their materials anymore. This needs to be considered. This is important for what we plan. We need factory layouts. Priedemann is designing aluminum production factories. This was our core business. That was one of my first works for Al Ghurair, for the Burj Khalifa development, what brought me into that world to create their factory, even knowing that later a lot was produced in Far East aluminium. But this needs to be done. You need qualified people to design factories that proper installation and quality can be introduced to the market. People need to be there when it is produced, and people need to be part of the local testing. And when you hire somebody to join a testing, don't get scared if they write you, after it is tested, we stay another 3 days. When the dismantling is happening, all the cheating on tests get exposed when you take out what have been installed and tested. I have seen things, oh, you have seen things. I mean, clicking magnets on aluminum profiles where a ton of steel was in and you were wondering why under wind load there is no transformation. There is so much cheating going on. So you need to stay there when it is taken out, that you see in detail if it was tested, what is qualified. Because a test on a test rig is a certificate telling you that the design is appropriate, not the execution on site. The execution on site, you have to test after installation on site with blow door tests. A testing rig is approving the design approach of your team. And this is something where your team need to be there. And your team need to be on site. And this need to be qualified people. I have seen appointed people in King Abdullah Financial District doing quality checks on things with an understanding of curtain wall where I have to say that would be not even trainees in our setup in Germany. Siteworks is lousy. Nobody want to be there, but you need the best brains there. There is experience required. A person who never builded a curtain wall cannot justify on build quality. These are theoretic people. You better leave them somewhere. If you select quality inspection for execution work, this need to be installers and fabricators who have done that. They understand what is going on, and not in theory out of a book. It is miscontracted. It is under the liability of clients to avoid that the wrong people appear on site based on the cheapest price tag. Don't wonder if it goes wrong if you do not invest in this control. So it's not about idea, it's about making things happen. And that needs the right decision. 1 minute, 12 seconds. Some work we executed. Typical complex project. Let me go back. Not enough budget for us to really go into it. So what we studied were just these critical areas. What do you see here? This point, it is not that you need to do all and everything all the time, but we studied that. We gave a qualified input in tender stage, how to develop a system to accommodate all the different areas, how to have thermal insulation where it is required. We tested the movement on the system and all this, that the accommodation of vertical movement and tolerances can be accommodated, and then we gave it into the market. And it was successful executed. A limited effort on a limited budget from the right people in time. This is something you can do. NPP Control Tower, Doha. We have done that with PLP architecture. An amazing project, interesting because it started with triangles to get around the curve. That cost money. Cutting a glass and throwing half of it and cut it away, or however you name it. And it introduced a diagonal in a facade. The architect didn't want it. Finally, it is more costly than the other side with the cold banded glazing. And that time, there was not enough understanding. So we got a letter of no objection from the client, turned from the facade consultant to the facade engineer in charge with the fabricator, and executed the job under our PI insurance. We trust our advice. So for that reason, we have the balls to stand for it. If you want us to do what we told you will work, we take it into the next level, and we go from consultancy into engineering and execute it with a lower educated fabricator into success. It worked, and it goes on. Same in Russia. This is a human being down here. This is a unitized panel, 6 meter by 12 meter, one panel, 8,400 kgs. Never done before in the world. We could not find a fabricator to do it. Everybody was freaking out. We said, don't worry, we do it by ourselves. Give me a fabricator in Siberia. And we have taken this. Foster and partner were the architect, we were the consultant. We took it into final execution. We worked on it. We built it. A lovely mock-up, very cost efficient and sustainable on the left side. Then we developed a system with Schüco before we knew who will be the fabricator. Interesting. System design was ready before a fabricator was appointed, because we understand what is required for the time. We did our own digital printings. We created a factory. We bought the machines with the client. We programmed from Berlin in Russia a welding robot working 18 hours on one steel sheet to do all this work for us. Installed on site because too big. We're hanging it, delivered the job, and created an stunning thing. I need to stop. I show you one more thing. An adaptive facade, we make it fast. We have an R&D division to create technology on things being demanded for tomorrow. We had the idea on working on a shading system based on shape memory alloys. This metal remembers to have which foam under what temperature. So we are using that to drive active shading systems where no external energy is required for movement anymore. If it is getting heated up, the material understands what to do and is moving the shading system. It is installed in Oman now. It is a future research project. We have the product Adaptive Wave, which looks like eyelids, I would say, sexy. And what you can see in that image is how it opens and closes to adjust on the air inlet into the room, and all this without an external energy. It is fully internal driven by shape memory alloy materials. The same we did with the mesh textiles, what you can see here moving back and forth to adjust the air inlet into the room. And this is the installation in Oman. And I think this is something, because time is out, we have to, please mind the gap between tender and construction. Keep your team on board when you want to go for it. Don't fire them after they delivered the specification because you think you can control it alone. You can't. The shit is happening when things get executed. Keep them in liability. Give them the extra 100,000 euros and let them stay in liability on what they told you what will work. You can't look at your competition and say you are going to do it better. You have to look on competition and say you are going to do it differently. We have our own way, our own interpretation on R&D, consultancy, engineering, and delivering and responsibility. Everybody gets his own way into success. We think this is required when Saudi want to do what is planned for Saudi Arabia. We are very happy to be here. What is key to deliver landmarks? It is strategy, it's not technology. You need to know what you want to do, and then you can do. Thank you for your time, and enjoy the evening.
Thank you very much. I think you have covered all topics from maintenance, knowledge exchange, sustainability, efficiency, cost. So thank you very much.
Thank you very much.
Allow me now, please, to introduce Phil Schneider, the head of sales in EMA, and Peter Kay, ME Sales Director. They are going to talk about the ETFE systems. They have been part of very successful projects, of which are King Abdallah Gardens, Al Rahba Park, and the Avenues series. The floor is yours.
Now, I think you hear me? Yeah, perfect. It's working. Thank you, Lars, for your impressive words. We will go to that a little bit as well. Something that you mentioned of the warm welcoming here in Riyadh, I can underline that. I have to admit, I have been here already a lot of times in Jeddah, in Daman, and Riyadh, and last week was the first time going to the Red Sea coast and Tabuk area. It's also very, very impressive what's happening there, and hopefully we can also be part of it. And me being a lightweight structural engineer, I'm talking about lightweight structures. And this is a project that looks a little bit out of space. But what is it? Before I solve the riddle, I would like to go into the past. It's 1960. Buckminster Fuller had a very visionary idea, a utopian idea, covering the whole of Manhattan with a transparent geodesic dome. The idea, the goal, is to create a temperature-controlled space. So therefore, in winter, you don't need heating, but in summer, quite important, also for case A, you have much less air conditioning. But how do you do that? How do you cover such a large space with a transparent material? There was no material back in these days. Which doesn't bring me to this picture, but have a look into it. This is a shark pit, no use at all in the middle of UK Cornwall. And this is what we have created. A lightweight dome used with ETFE foil. We get later to that, what it really is. Architect was Grimshaw's, 30,000 square meters, the first big project executed with lightweight material or with lightweight transparent material. So have a look into that picture. I really love that because it shows you some of the USP that ETFE will give you. First of all, the transparency. So it's fully transparent. Second of all, it's not only transparent, but also transparent to the UV. Plants need UV. They need that for their photosynthesis, and therefore a very good advantage. And last but not least, if you look into the structure here, very elegant. The ETFE system itself only weighs 5 kilos. The substructure below, very efficient, in that case 30 kilos a square meter, which is very, very nice and elegant. In order to understand the size of the panels, you can see here this one of our guys doing some maintenance. The dimension was 9 meters times 9 meters for all those hexagons. But it's not only the lightweight characteristic, also the lighting itself, because the foil can really distribute the lighting. It reflects very well, therefore it can also be host for a lot of events and shiny, a glowy candy effect, we often call it. And last but not least, material durability, something very important, and people ask here, is this material durable? You can have a look here. It's now 2021, so 20 years from when we built that project. No cushion was exchanged, and all the world leaders were meeting in Cornwall. It's still there, it's still very nice. And now we are going to Saudi. Project, the video that you have just seen, will be the biggest ETFE project in the world. It will be one of the biggest botanical gardens in the world, and this botanical garden creates really new atmospheres and new spaces. We are having 7 different spaces with some tropical gardens, with some semi-tropical gardens, with some winter gardens, all in there, creating a very, very, or I would say, fantastic future botanical experience. So we are on site. You can see some pictures of me and my colleague. We will hopefully be finished by end of the year, and this is only one of the landmarks. The opening, I guess, will be in 2 years, but let's go into the future ideas. So you remember Buckminster Fuller? Now you have the envelopes that we are creating also here in Saudi with the biggest botanical garden. And you remember the huge dome that Buckminster Fuller said? This might be a little bit geeky. It's Star Wars, Mandalorian, a planet, it's called Plaisir 15, a series, and they had the idea to also cover the whole space. And we said, look, it's actually structurally not working with these glass panels, but it could already be done. It could be done with ETFE if the system only weighs 5 kilos a square meter. So our concept designer who loves Star Wars had a nice concept of how it could look like that. But you see a very green atmosphere, but you can also do it in a desert. And what you can see here is actually PV panels that can rotate with the sun, creating total new atmospheres in this region. And I think, Peter, I won't steal your time. My colleague Peter will talk a little bit more about the avenues.
Good morning. Good morning, everyone. I'd like to start with a case study that's been very important for both the client and Vector Fortech and indeed ETFE in the region. I remember being in Kuwait, one of my first trips to the Middle East, many years ago now. And I happened to be there during a very, very hot summer's day. I decided to take a walk out the hotel for exercise, very quickly retreated, and it was making me think, you know, where can I go to get some exercise? I want to be in an outside space. The same thing, similar with a client here in Kuwait. They had a shopping mall, an existing shopping mall, where they had the 2 first phases were built with glass roofs, and their biggest issue was they wanted people to come into a more serene environment. And the problem they had was that they found in the glass areas or beneath the glass areas in space that it was quite noisy, so the people's noise internally was reverberating down, and secondly it was quite dark. So what they did, in conversations with us, Vector Fortech, we convinced them that we could come up with a solution that would essentially give them an outside space with internal comforts. And the main aim really was, it changed the face of the way I thought about shopping malls. Many years ago when I was young, a shopping mall was just to go and shop. Then it evolved into something much more, a cinematic experience or an eating experience. But here in QA, it turned into an exercising experience as well. So let's talk about why. Why has ETFE achieved what glass couldn't for them? And let's go through briefly the big reasons. And the main reason, or reason number one perhaps, is big span. ETFE is super lightweight. So as Phil said, we're talking maybe 5 to 6, 7 kilos a square metre. And what that does, that impacts on not only the material, it impacts on the structure supporting and the framing. So what we get is much more light coming into the space. The other big factor is ETFE is acoustically transparent. So what that means, any internal noise dissipates out through the roof. When I take clients to the avenues, being a sales guy, the first thing I always do is take them through the glass area. And it's very noticeable that it's dark, it's noisy. Almost instantaneously, when you walk into the ETFE area, the environment changes. It's a very serene, calm area. And in fact, what the client has done over the course of time is basically all the restaurants now pretty much are in that area. So people can eat in peace and then take a stroll. One other advantage with ETFE, or one big advantage, is not only when people walk along the Grand Avenue, nobody looks up. And that means ETFE is doing its job. It means people feel they're in an outside space. When they get to the Central Forum, it's a different ballgame. People stand there and take pictures. You often see, not cameras anymore, of course, telephones or mobile phones come out and people are taking pictures. And this shows that what we can do with ETFE is not just functional in terms of turning the space into an outside space, but creating different geometries. So it's an architect's dream or a client's dream where we can do almost anything with ETFE, and the advantage again is the panels are so much bigger. Just another shot, but it's rather beautiful. It is a stopping point almost. On the back of that, the success of that, they actually went on. So the first ETFE phase, I think, was 14 years ago. And then we went on to another couple of phases. The client now has expanded into the KSA. So we're currently working on the Avenues Riyadh, which is a very exciting project, all in the same mode as the Avenues QA, pretty much. We're due on site, I think, March, April next year, and I think due to open, I think, the year after. Avenues Kobar is in design stage and due on site next year at some point. We'll just briefly go through some technical details because I'm looking at the time as well. If you think of ETFE, if you think of glass roof or facade, if you think glass, think ETFE. It's similar in some aspects where you need a support structure, generally steel. You also need an aluminium framing system, which is a bit like a glass framing system. The only difference, instead of glass, we use our ETFE cushion system. What often's talked about, when Phil was talking about lightweight, the average thickness of an ETFE floor was about 250 microns, so incredibly thin. And I think this just demonstrates the strength of ETFE when inflated. This was one of the Eden Project cushions, quarry cushions in Cornwall, where we demonstrated a car being lowered. Talk about durability. So ETFE, if we compare to glass, glass has been around for hundreds of years. ETFE is still relatively, compared to glass, in its infancy. So the first project was built in 1983. And what we've learned from that project is that ETFE is completely resistant to ultraviolet light, atmospheric pollutants. It seems to just go on forever. And I think if we look at the image here, we can see a very young Stefan Leonard, the inventor of ETFE or ETFE solutions, and then Stefan 35 years later, and the only thing that's aged is poor Stefan. This is quite important. What often comes up, certainly in the Middle East region, is solar thermal, so G values and U values. This is probably one of Vector's smallest projects ever, but what the architect wanted, You can see here that this is glazing. So this was a glass dome at the Mall of the Emirates. But what he wanted was a central oculus to be seamless, so no framing. That was impossible with glass because the panel was too large. But what we had was the same solar thermal. We had to produce the same solar thermal comforts as the glazing. But what you can see is, oops, excuse me. What you can see is so much more light comes through the ETFE roof with exactly the same characteristics as the glazing. Sustainability, ETFE, I'm going to speed through a little bit because of time. Sustainability ticks all the boxes for sort of LEED and BREEAM. It's completely recyclable. And another advantage is because the material lasts so long, you very rarely have to get to that point of recycling. On the back of the Avenues project, it's now well recognised within the Gulf region that ETFE is a bit of a go-to product. So many different products, from botanical gardens to shopping malls to different infrastructural projects, have been built. And leading on to what's important for you guys here today is the KSA. So the KSA now, we built a project a couple of years back in Jeddah, a shopping mall. As Phil mentioned, we're working on the world's largest ETFE project, the King Abdullah International Gardens, which for me was about 10, 12 years in the making. It's hugely exciting. And of course, the shopping mall projects that we spoke about already. Just to finish up, and I've just got time to finish up actually, we built a very exciting project for the Dubai Expo, where we actually used a very first in the industry, where we used a carbon fibre frame. Incredibly exciting because it was incredibly lightweight, not just the ETFE, but the structure as well. Obviously very expensive, but it leads me on to the expo here in the KSA. And I think what I've noticed, I've been coming here now for just over 10 years, and the vision in the KSA has completely changed. It's some of the products you're talking about and some of the products we're going to hear today, not just our products, but other products, it's very exciting for the future. And I think what it lends for us is we would very much like to be part of the Saudi Expo, to develop something completely different, completely bespoke. And I think that's all from me. It's been a pleasure talking to you, and please feel free to come to our booth and we'll explain a bit more. Thank you.
Thank you, Peter. Thank you, Phil.
Yeah.
Very inspiring for a landscape architect, not only an architect. Thank you very much. Allow me now, I would like to introduce Mr. Samer Abdallah. He is an architect and an urban planner, and he is the lead operation and technical manager at Altheyab Architects. Samer had worked on a variety of projects, residential, tower, resorts, and his focus is, I think, on maximizing durability and performance. Samer, the floor is yours.
السلام عليكم. صوت مسموع. Hi everyone. I'm happy to be with you today. جدا مبسوط ان معكم اليوم. غالبا بتكون الكونفرزيشن اغلبها بالعربي شوي لان عندي مواد كثيره ودي اتكلم فيها. Maybe I try to speak with Arabic most of the conversation. So تحملونا. طيب كلامنا اليوم عن موضوع the breaking mood. Breaking the mood and how we can bring the way of the processing in Saudi Arabia. الآن احنا محتاجين حابين ندخل في موضوع التغيير وإعادة تعريف الواجهات. بمعنى اليوم عندنا التركيبات الموجودة والمشاريع الموجودة عندنا في البلد كلها استراتيجيات تصميم قديمة. محتاجين نغير كل الداتا الموجودة عند الناس بحيث ان احنا نشتغل على موضوع استراتيجيات جديدة حديثة لمواد جديدة تبع الاستدامة، ونشتغل على موضوع توفير الطاقة في موضوع التصميم. اوكي. طيب عندنا شلون نعرف او شلون نقدر نسوي تطوير لموضوع ال الواجهات. عندنا الواجهه هي الشيء الرئيسي الموجود عندنا في المبنى. الانطباع الاول يؤخذ على شكل الواجهه. التشكيل في الغالب يكون كانها فستان العروس النهائي، بمعنى ان انا اليوم لما يكون عندي واجهه محتاج اني انا اتكلم على اكثر من عنصر فيها، وفي الغالب يكون العنصر الجمالي. العناصر اللي عندنا كيف نبدأ نتكلم عليها كتعريفات للواجهة. عندنا اللي هو الفيجوال ماستر بيس. طبعا هذا اللي كل الناس او كل المعماريين او كل المصممين يشتغلون عليه، وناسيين باقي العناصر. طبعا الروائع البصريه هذه تكون ناتجه عن ابداعات للمعماري، ابداعات للمصمم، كل همه انه يبين مشروع جدا فخم في مكان كويس بحيث انه يعمل لاند مارك عليه. طيب عندنا امور اكثر اهميه من هذا الكلام. السستينابيلتي هذه اللي هي الاستدامه اللي تكون معنا للمبنى، وهي توفير الطاقه الموجوده وكيف اقدر استخدمها في موضوع الواجهات. طيب عندنا كمان لازم نستخدم موضوع التقنيات المبتكره، مثل ما تفضل السبيكرز وتكلموا عليها، اللي هي شلون نقدر نبين ونحسن الاداء الهيكلي للمبنى. وهذه طبعا تكون كامله في موضوع الانوفيتيف تكنولوجي. التحديات الحاليه الموجوده عندنا في المملكه، عندنا اكثر من تحدي واغلبهم تحديين. طبعا عندنا الكلايمت كونديشنز اللي هو الموضوع المناخ، وفي نفس الوقت يكون معنا السياق السياحي الثقافي والموجود في اللوائح المحليه. عندنا اليوم لما نيجي نتكلم على موضوع التحدي او السياق الثقافي الموجود، هذا دائما البلد تعطينا كودز نشتغل عليه، وهذا مطبق في اكثر من مكان واكثر من حي، ومثل كود وادي حنيفه، مثل الكود السلماني على طريق الملك سلمان. هذا حدنا خلانا نحتد على ان احنا نتماشى مع الثقافه والكلتشر حقتنا الموجوده في المملكه، وفي نفس الوقت نحترم الانماط الموجوده في التراث حق السعوديه. انا اليوم لما اشتغل الواجهات مو معناها قزاز والومنيوم. الواجهات انا داخل على قصه انه ضروري نستخدم المواد الموجوده في الارض. المواد الموجوده مثل مواد طينيه، رمليه، مواد تعطيني الكلتشر اللي احنا نشتغل عليها. التقلبات الموجوده عندنا في المناخ طبعا هذه جدا مهمه، ان احنا نعرف ان البلد هنا بلد صحراويه جافه جدا جافه، عندنا حراره عاليه. شلون نقدر نوصل متانه المبنى والابتكار حقنا ان احنا نخدم على اساسه. اوكي. طيب الامبريسنج اوف انفيتيشن، هذا احتضان الابتكار، الحافز التقدم. طبعا لازم لما يكون عندي ابتكار واضح جدا اني انا بكون داخل على تحدي. لما اطلع تصميم او اشتغل بطريقه معينه، في الغالب يكون عندي تحدي او عندي مشكله محتاج اني احلها. المشاكل في الغالب تكون حلولها بسيطه. الحل او التعقيد اللي قاعدين نسويه هذا يعطينا اثراء في اختيار المواد، واختيار المواد هذا شيء اساسي جدا في موضوع الواجهات. الماتيريال سيلكشن للواجهه نفسها، بحيث ان انا يكون عندي ماتيريال القزاز هذا كماده اساسيه ان كان في المباني او في الابراج. نفس الشيء موضوع الماتيريال اللي بنختارها من الطبيعه، واللي كلهم لازم يكون عندنا فيهم كفاءه، ويقدم كله على موضوع الاستدامه. طبعا الاستدامة وتوفير الطاقة شيء أساسي ومطلوب عندنا من التصميمات اللي غالبا ممكن نشتغل عليها. نتكلم أيضا على موضوع الانتجريشن فور سمارت تكنولوجي. هذه في الغالب حنا نشتغل عليها أو حابين نشتغل عليها على أساس إنه شلون نقدر نبين للناس المكاتب أو المباني الموجودة نقدر نتعامل فيها عن طريق استشعار أو أجهزة استشعار خارجية أو داخلية، بحيث إنه يكون عندي زي مش زي لوفرز زي دبل سكين. في الحالة هذه نقدر إن حنا نتعامل معها. طيب creating iconic landmark. طبعا هذه لازم احنا واحنا بنشتغل اي معماري اي مصمم كل همه انه يعمل مبنى قوي. المبنى القوي هذا وش معناه؟ معناه انه والله اكثر من محدد، ان مساحته، ارتفاعه، شكله، مكانه، كل الامور هذه تبين لنا انه محتاج انه يكون لاند مارك للمبنى. عندي لازم احترم الهويه الثقافيه للبلد الموجودين فيها، لازم نحترمها كهويه ثقافيه، وناخذ معنا الحاله الجماليه للمبنى مع المساحات اللي ممكن تساعدنا على تحقيق الكلام هذا. طيب الآن أنا علشان أقول إني أنا عندنا تعريف أو تطوير للوجهات الموجودة معنا، عندنا أكثر من بند، بس أهمهم موضوع تحسين الطاقة وموضوع الجمالية والوظائف المبنى. تحسين الطاقة عندي أنا اليوم إذا كان الوجهات المحسنة طبعا تقلل من فعالية الحرارة وفعالية استهلاك الطاقة، وهذا اللي يؤدي إلى توفير كبير في التكاليف. نفس الشيء موضوع الجمالية والوظيفية للمبنى اللي احنا نشتغل عليه على أساس إن يكون شاغل المبنى ومرتديه في حالة كومفورتابل، وحتى الزوار واللي يعني يتفرج على المبنى من الخارج يكون عندهم تصور كامل للتصميم. في وقت اختيار الماتيريالز في سمارت ماتيريال سيلكشن لازم نبدأ نشتغل عليها، بمعنى اني انا اليوم ادور على الماتيريال اللي فيها ديورابيلتي للمبنى، ادور على اختيار المواد المتينه والموفره للطاقه، وفي نفس الوقت اللي تلبي الظروف البيئيه في المملكه. وطبعا مثل ما احنا عارفين الظروف البيئيه المملكه جدا صعبه، حراره، رطوبه، عندنا جفاف، كل الكلام هذا يحتم ان الظروف البيئيه القاسيه في المملكه تستخدم مواد ذكيه نقدر نقلل من الحراره المرتفعه وفي نفس الوقت يكون فيها سيفنج للطاقة. موضوع الاستدامة هذا موضوع جدا قوي، لازم كل المصممين يعني يدخلوا فيه. في نفس الوقت المطورين أو المؤسسات اللي داخلة في موضوع التطوير يكون عندهم big knowledge فيها. ممكن يكون يدفع أكثر شوي، ممكن يكون في عندنا تنوع في اختيار المواد، مواد مستوردة من الخارج، مواد موجودة عندنا، لكن في النهاية تعطيني سيفنج قوي جدا للطاقة على المدى البعيد. ومن ضمن عوامل المتانة الموجودة عندنا في التركيب واختيار المواد فيها طبعا ضروري جدا مراعاة انه يكون طبعا نحترم التمدد الحراري، نحترم التمدد الحراري مع المقاومة التآكل، وفي نفس الوقت يحافظ على برودة المبنى وجودة المعيشة فيها. طيب الأهم من المتانة أو اللي ماشي بارلل مع المتانة هذا بيكون موضوع التوفير للطاقة. طبعا اذا كنا قاعدين نتكلم على توفير الطاقه هذا معناتها اني انا قاعد ادور على مواد تعمل سيفنج، مواد تعمل فنتيليشن للواجهات، تبريد كامل للواجهات، بحيث ان احنا نقدر نتحكم في المباني وفي نفس الوقت الجماليه والبنيه التحتيه للبلد. عندي طبعا بعد هذا كله تحديات قاسيه، تمام، تحديات وقيود قويه جدا، تشالنج اند ليميتيشن. هذا يتحدد في أكثر من عنصر. منها أول شيء إن دائما المستثمر أو المالك أو يدور على محدودية التوفير. فأنا اليوم لما أوفر، لا هذه ما فيها توفير، في الغالب يكون فيها دفع أو برايسنج أعلى، لكن تعطيني على المدى البعيد قوة وفي نفس الوقت متانة. عندي برضو التكاليف المرتفعة، عندي الخبرات المحلية المحدودة. يعني عندنا هنا الناس الموجودين لسه ما عندهم الوعي الكافي إن احنا نشتغل على موضوع المواد اللي هو اللي نسميها العمارة الخضراء، وفي نفس الوقت تشكل عندنا عقبات. طيب عندنا بعض الأمثلة اللي تم استخدامها في المملكة. وهي أمثلة طبعا موجودة وقائمة، مثل مركز الملك عبد العزيز الثقافي. طبعا هذا أخذ من البيئة، أخذ من الشكل الحضاري للبيئة، أخذ من موضوع التكتشر مع الفانكشن حق المبنى. برج الفيصلية طبعا أخذ، خلينا نقول إنه دخل بشكل أنيق، أخذ وجهات، اشتغل على موضوع الكاسرات، على موضوع تقليل الأشعة الداخلة. في نفس الوقت نتكلم على إنه تصميم فريد. نفس الشيء في موضوع الملك عبدالله فاينانشال ديستريكت، هذا طبعا غني عن التعريف واشتغلنا عليه كمتتابعة بصرية. بالنسبة لموضوع المتتابعة البصرية، يعني أنا حاب إني أتكلم على visual sequence، إن هذا من الأشياء المهمة جدا ممكن نشوفها أو نعتمد عليها أو نشتغل عليها. المتتابعة البصرية إن طبعا جدا مهم إني أكون ماشي في الطريق أو في الشارع ويكون عندي تباين طبعا في الارتفاعات. تمشي تلقى برج عالي، لا مبنى منخفض، لا ارتفاع ما ادري ايش. وهذا اللي قاعدين نطبقه احنا في طريق الملك سلمان، ان في عندي كود كلنا بنشتغل عليه. الكود هذا اللي هو استخدام المواد من الارض. طبعا بيكون اتوقع في الملك فهد برضو نفس الشيء، بدأ انه يوقف موضوع التعميدات على اساس انه ممكن ينزل كود جديد خاص بالشارع، بحيث انه يبين او يعطي متتابعة بصرية قوية للشارع من اهم الشوارع الموجودة في البلد. طيب بنعرض لكم بعض المشاريع اللي تحت تصميم مكتبنا، اللي تبين وشلون نقدر نروح على موضوع الكالتشر وموضوع الماتيريالز اللي ممكن تكون اللي بنستخدمها في المبنى، اللي تحافظ معنا على موضوع الاستدامة، على موضوع توفير الطاقة، على موضوع الخامات تكون فيها فنتيليشن، خامات سهلة موجودة متواجدة. مشروع زي هذا طويق تاور، هذا المشروع اسمه برج طويق. برج طويق هذا على الملك سلمان، يمكن من المشاريع اللي الايكونيك اللي ممكن اللي بتصير على الملك سلمان. بدأوا فيها الحفر من الشهر اللي راح، متوقع يكون فيها صحوة قوية. المشروع هذا عبارة عن، طبعا هو كونستراكشن عادي، بس الفكرة انه جبل منحوت او قطعة جبل طويق اخذناها وتكلمنا عليها، بدأنا نعمل فيها موضوع الفينيشنج مع التفريز مع الليجل شيب الموجود، ويبان معنا حتى في التشطيبات الموجودة والإنارة اللي كأنها كاف لايتنج. اوكي، نتكلم على موضوع الديورابيليتي في الموضوع. انا عندي هنا اللي يشوف المشروع الوهله الاولى يقول لك والله هذا ممكن يكون حجر، واحد يقول لك لا GRC، واحد يقول لك لا ممكن نشتغل على الفابريك ماتيريال او نشتغل على السيمنت فايبر. يعني في اكثر من اوبشن نشتغل عليه، لكن اختيار الماتيريال او الماتيريال سيلكشن يعتمد على اكثر من عنصر. عنصر القيمه الماديه، عنصر الديورابيليتي حقت المشروع، وعنصر التركيب. فمن التحديات القويه واللي الحمد لله لقينا حلول لها طبعا، وان شاء الله يكون من المشاريع القويه في البلد. اوكي، كيان تاور من المشاريع اللي ممكن نتكلم عليها إنها مشروع ايكونيك على طريق العليا. المشروع هذا التحدي اللي فيه إنه فري سبان للمش اللي نازل. أوكي، كان في الغالب إنه يكون جلاس، ولكن حنا فضلنا إن نشتغل عليه مش. الجهة الأمامية اللي فوق التاج حق البيلدينج. المشروع هذا كانت فكرته إنه مثل العباية السعودية أو العباية الخليجية خلينا نقول. كان دبل سكن، وعلشان تقليل التكاليف برضه قللنا شوي وصار وان سكن فساد. فكرة المشروع إنه شلون أقدر أتحكم في الطاقة، أوكي، وأعمل سيفنج لها، واللعب كله بيكون على اختيار ماتيريال الزجاج. والسبيسيفيكيشن تكون فيه قوية بحيث إنه يكون اليو فاليو والسولار جين افكت يكون أقل شوي عن النورمال جلاس. مشروع من المشاريع الرائدة برضه في طريق الملك سلمان، وتحدي جديد على الطريق. مشروع اسمه هاما تاور. فكرة المشروع جذع نخلة، بحيث إن أنا أقدر أستخدم المواد اللي موجودة في الأرض في الطبيعة وأعمل فيها المشروع. مشروع طبعا كله جلاس، عشان كذا اشتغلنا على الدبل سكن، يكون عندي فراغ بين السكن الأساسية والمش الموجود الخلفي، يعطيني فرق تهوية. لما يكون عندي حاجة زي كذا، عندي سوليد وفويد، عندي خلينا نقول فرق ضغط في دخول الهواء، يعطيني تبريد دائم للمبنى. فهذه فكرة المشروع الأساسية. مشروع طبعا امتداد لمشروع التاور، مشروع الماجد اوفيس. كيف نقدر نشتغل على موضوع الفنتيليشن تبع المشروع. طبعا هذا برضو دبل سكن، ما ادري كيف نسوي البوينتس. هذا دبل سكن للواجهات الرئيسيه، وعندنا الكورت يارد يكون كله زراعه، ويعطيك فنتيليشن طبيعيه مع سكاي لايت مفتوحه، او خلينا نقول مش مفتوح. طبعا هو امتداد للتاور اللي كنا تكلمنا عليه قبل شوي. فكره المشروع انه السكن هذه شلون نشتغلها وهي على طريق مهم وكود ملتزمين فيه. نشتغل عليها في ماده تراكوتا، وفعلا سوينا سامبل عليها ونجحت، وان شاء الله بيكون من المشاريع الايكونيك الموجوده في الرياض. اوكي، زود ريزيدنشال مشروع مهم، من اول المشاريع الريزيدنشالز اللي ممكن يكون فيها دبل سكن او لوفرز. اللوفرز طبعا خلينا نقول الريزيدنشال في البدايه عشان موضوع الكلتشر اللي عندنا في السعوديه. الكلتشر الموجوده عندنا انه فيه شوي خصوصيه، فحبينا نسوي المش، موضوع المش، لان الجلاس ودبل سكن مضطر تحط كيرتن داخليه. فاحنا اليوم نشتغل على موضوع الدبل سكن، منها نحافظ على الكلتشر والخصوصيه للساكنين جوا، وفي نفس الوقت تشكيل خارجي للمبنى. الفكره الرئيسيه كانت على موضوع السكن الاساسي، اللوفر الاساسيه، تمام، على اساس موضوع الفنتيليشن وتقليل الطاقه والاستهلاك، ويعطينا استدامه اكثر للمبنى. طبعا مع التاكيد على نوع القزاز انه يكون جلاس فيه محافظه طبعا يو فاليو عالي، وسولار هيت جين عالي، واس تي سي عالي. فبرضه المشاريع قويه. المبنى اللي جنبه هذا طبعا هذا هوتيل، ما ادري كذا هوتيل. لو تلاحظ تلقى ان الشبابيك نفسها داخله جوا، بحيث اني اعمل عمق للشباك يعطيني كانه كاسره طبيعيه، ويقلل من دخول اشعه الشمس والحراره. عود ريزيرف من المشاريع القويه، 82,000 متر الارض، مبنى تجاري سكني اداري. الفكره برضو الرئيسيه فيه موضوع المش في كل الباترن الموجوده عندنا كمش كباترن اساسي في المشروع. حبينا برضو نشتغل على موضوع الدبل سكن والتنوع في الكتل وإظهار قيمة المشروع كمشروع أساسي. نفس الشيء الفنتليشن، موضوع التحكم البيئي في المشروع. مشروع جدا مفتوح، في فكره انه والله كانه كورتيارد كبير محتضن للمبنى بالكامل، فحنا حبينا نشتغل عليه على موضوع السكنز والفنتليشن تبع الزراعه. المشروع الاخير اللي بعرضه عليكم اليوم مشروع فكرته انه اتس اوكي فنتليشن بات وذ تراكوتا. التراكوتا طبعا منتج جديد، حابين ندخله البلد، حابين نشتغل عليه، حابين ان احنا نتكلم فيه، بس الفكره انه وشلون الفرق بين الجلاس والتراكوتا والفنتليشن بين التراكوتا والمين فساد او البلوك الخلفي. طبعا فنتليشن طبيعيه تعطيني تبريد كامل للمبنى، قزاز مواصفاته عاليه، معطيني يو فاليو قوي. اوكي، الخلاصه ان انا اليوم ضروري اكون عندي معلومه على انه الوجهات متطلب ان احنا جدا ندرس المناخ بشكل قوي، وان احنا نشتغل على موضوع السياق الثقافي والاستدامه. في نفس الوقت الاستراتيجيات التصميم لازم ندخل في مجالات الاستدامه وتوفير الطاقه، ونحترم الكالتشر حقت البلد. ويعطيكم العافيه، وسعيد جدا اني كنت معكم اليوم. تجربه جديده حبيتها، وان شاء الله نشوفكم في المرات الجايه. شكرا.
شكرا محمد، شكرا سامر. And يعني you brought us back into the context of Riyadh, the introduction of a new material, the terracotta and the facade. Very interesting. I now would like to announce Mohammed Bahsh. He's a senior manager in tensile architecture for Serge Ferrari Group. Mohammed, the floor is yours.
Good morning, ladies and gentlemen. It's a pleasure for me to be here today. Today we want to talk about something quite different. Something lightweight, flexible, but durable. Okay, so we're going to talk about textile and technical fabrics and from Serge Ferrari Group, and how these can contribute to the next success, to your next project. Basically, we will go on to start just a quick introduction to the group. We in Serge Ferrari are active in 4 main markets, and those are in the tensile architecture, which covers the roof, facade, acoustics, etc. But also in the modular structures, which is anything related to the events or temporary structure. Solar protections, this is something very important nowadays with the projects in Saudi Arabia, with the rise of tourism industries. We will see that a lot of indoor and outdoor terraces and walkways. But also one of the key active sectors we are in is in the outdoor furniture and also yachting. We're going to take you into a quick corporate video to introduce the group before we start in our presentation today. So back to our topic of today, facade. We know in architecture, the facade of the building is often the most important from a design standpoint, as it sets the tone of the building. So it's very important to have a landmark face that create the identity of your building. That it has to also be different and also to be contemporary or adding more value into the building. But most importantly, it has to be functional. It has to last, and it has to last nowadays in this weather, with the selecting of the material, it has to last for generations. So today we're going to summarize actually the key feature and benefits that we can go for hours on them. But the most important things that facade or textile can contribute to your next project, most important one basically is the thermal insulations. And you know, with the thermal insulations, usually or typically the high performance facade, what we expect from it is to improve the indoor environment, reduce the heat or the solar gain, but also increase, but also reduce the overall energy consumptions into the building. So we look for, beside the privacy that it can provide, we need the most important things to think about how we can maximize the natural daylight. So basically, people perform better in daylight environment. Daylight, it has a lot of associations to the improving mood, productivities, enhancing morale, etc. And how fabric with the micro-perforating structure will heavily contribute to these factors. We take a good example in this one here. It's Fritz Institute in Germany. This is the second skin facade structure. Helps here actually to not only reduce the final energy into the building, but also to reduce the glare, protect, improving the visibility from inside to outside, but also having an excellent solar protections and thermal control. The second part here is we talk about identities. Now, our colleagues in the industry, the designer, the architects always look at something new, something contemporary to add on their projects. And nowadays we'll see projects in different industries. And the most important unique part here, that's the fabric. Using fabric into your architecture will help to transform the building into something quite phenomenal. And one of these pillar, let's call it, it's the performance during the daytime and the night time. If we look at this one here, the LED, using the LED in facade or in fabric, technical fabric, help actually to transform the complete envelope into something quite interesting. It's not only LED, but you still can also project characters into it. The second part is the 3D. We talk about when we are applying the fabric into facade structures, we have two different parts. It can be modular or it can be tensioned structure. But also, one of the most important things, you can use the 3D elements into your building. And by doing so, this is, for example, Tajreed building here in Saudi Arabia. It can provide an excellent identity into the building. During the daytime, it provides an excellent privacy, yet with thanks to the micro perforated mesh, it provides an excellent visibilities for those inside the envelope. The third one is theme. I mean, if you would like to add more of a identity into the structure, think about printing. We have colors, okay, and colors that can last. But also, if you have something more, you want to go into more detailings, we can also do some kind of a printing into the material itself. The third pillar, which is the most important one here, we're talking about harsh weather, high temperature, humidities, etc., is how we're going to use the exterior facade skin to create more comfortable surface. And that's, as a return, it helped dramatically to reduce the energy consumptions. By doing so, if we look at here, if we apply the facade as an exterior shading or as a second skin, with the thanks to the natural ventilation scheme that will help to dramatically reduce the final temperature touching the surface or the glass, and that would help in return to reduce the energy consumptions and also to reduce the cost of AC for sure. There is the most amazing example of the system value is this 15 years old case study in Los Angeles. This is a Silva Spa public building in Los Angeles. Was built during the 60s. The building was suffer of a serious heat leak, and even at one point the owner were thinking to demolish the building. So basically here what happens is they thought in a reversible way. They want to keep the building, but they want to improve the thermal lock of the building. So basically an investment of $200,000 and has paid back only in 3 years by saving a $60,000 per year. So over 15 years study of this, there was a significant of $700,000 in the energy consumptions or the AC consumptions by simply just adding an exterior facade elements. And that's basically the concept is just a natural trade-off with air ventilations. Lightweight, it's not just a pretty face of textiles or colors or etc., but it is a mechanically strong. And that is the most important part. So it's a very lightweight. It's much lighter than steel. It's much lighter than any other material concept, but it is mechanically strong. And with this in mind, we can take it to a very high-rise building. We take an example of this building, 250 meter height. Of course, we have another one here is Burj Al Arab. Okay, fire characters, and that's the most important things. We talk about when we need to select a material, we need to look at the safety concept of this material, and most importantly is when we talk about fire. In Search Ferrari Group, we combine different technology under one roof. We have the fiberglass, we have the polyester, we have the STFE, we have different kind of technology, but we can summarize them actually simply in two categories. We have the PTFE composite, and then we have the PVC composite. The PTFE, it's something goes without saying. It's a non-combustible Class A material that helps actually to provide a solution, especially when fire safety is something cannot be compromised. It has to be at part of the envelope, part of the building. PVC, also PVC, it's a fire retardant, safe, it's non-flammable material, and that's of course can help also in different kind of solutions. Nowadays, we think of the fiberglass materials, the opening mesh. It is now a growing trend to be alternatives or as competitive as the steel mesh. Due to the first, it's non-combustible. It can last for 30 years, much lighter than steel mesh, but most importantly, it is a non-combustible fire rating. And if we look at the visibilities compared to the steel mesh, and you will see thanks to the micro perforated opening, you will see the visibilities actually between the fabric and the solid, the steel mesh. You will see that because of the micro perforating, you can still create a very comfortable envelope, a very comfortable space to stay in. Another features actually adding to those previous pillar is simply the retrofit and renovations. We have a lot of buildings in Saudi, mainly in Riyadh, that we need to pump new life by, and fabric can help actually to provide solutions. As I mentioned here, we have a group of products that please feel free to come outside to discuss that can provide an excellent solution actually to your project. All our products are EPD certified, and these are some of the most recent projects in Saudi Arabia. It's picking up actually as part of a new building, new constructions or a retrofit constructions. And because it's a flexible, you still can shape it, design it, build it in a different way that can help to boost the identity of your project. Since we have the vibes of stadiums, just for 2-3 minutes before I go out of this stage, I will go through the stadium. But before that, we will share with you this tremendous, nice 5G towers, which are built in Ummahat Islands. It just recently finished, and these basically an islands where they are building a zero carbon tourist destinations. There are 4 towers, 4G towers at height of 42 meters. They are the first project in the world where they utilized fully wrapped of fabrics. The fabric selected here was fiberglass mesh. It has an excellent sustainability through the longevities. It has an excellent fire rating. It has an excellent electromagnetic properties. But most importantly, it's a environmentally friendly productions. Stadiums, as we mentioned before, going into the stadiums, I will share with you our contributions in the FIFA World Cup in Qatar. But if we go back actually to the weather here, the challenge is always the weather, and the weather is put a pressure actually on the selecting criteria of the material. So basically, how membrane solutions, how we can contribute actually to maximizing your project value is by providing you a material, a technology, or a modified solutions to fit with your design that can have an excellent thermal and physical properties that can boost the longevities. A big range of different technology, including acoustic and transparent. And of course, one of the front runner of the industry, we call it, is the PTFE fabrics. And this is, of course, it's a longevity material that can last for decades. And always here important, together with our fabulous colleagues in the industry, to stress on the selecting of high quality material, a material that can last for generation, that is well tested, that has been under this harsh weather for decades. And that is the most important message to you here, okay? That quality cannot be compromised in stadiums. This is some of our projects. We can talk long, but to be frank, time is limited and they're looking at me to come off the stage. So I have to leave the stage. And please, we are outside. Just please come anytime for any questions. We are here to help. Okay, this is just a quick one. This is the STFE, structural transparent material, and this material simply is a structural. It has excellent strength that can provide an excellent a good UV ventilations to the growth of the grass into your building. Of course, we have also an acoustic solutions that can be used to enhance the interior envelopes of the building. Thank you very much for your listening.
Thank you, Mohammed. Thank you very much, and for sticking to the time. With his motto, doing the right thing today is one step closer to protecting the people of tomorrow. Allow me to welcome Donel Dippi, the technical manager for side-rise insulation.
Good morning, everyone. There's been a lot of talk about sustainability the past 1 month with the COP28 happening and everyone, getting on the bandwagon for sustainability. With SideRise, we believe that sustainability starts with saving lives, and that's what SideRise is all about. So we're going to talk about pacifier protection for external facade systems. SideRise are a 50-year-old company. and we've been growing from strength to strength. We have been developing passive fire protection solutions for the market for over 30 years now. And well, we have started up offices in the Middle East, in India, and in Singapore, and we have all the necessary testings and approvals to go along with that as well. We are represented in Saudi Arabia with our local partners who are our extended arm and are present for all technical and site services support called Physico, and they hold local stock as well of our product, because our manufacturing facility, we only have one, and that's based in Wales in a small place called Maesteg in the UK. So yeah, it's important to have local stock, and Physico are our local arm for that. So getting straight into the brunt of the presentation, why are we here? The aim, or what we are trying to do, is to educate the market and to promote that a balanced approach is required between active fire protection and passive fire protection. The challenge that we constantly see is that active fire protection, such as sprinklers, detectors, fire alarms, are given more importance than passive fire protection systems in the market. It is important that both the solutions should coexist and play an important role equally. Passive fire protection can only be done in the design phase of a job. So if you want to implement passive fire protection after 60% of the building is completed, it's impossible. So it's important to do it in the first instance and get it right. There are different facade types in which side rise cater to. I'll be focusing on curtain wall, ventilated and non-ventilated facades. Masonry facades are not really a thing in the Middle East. So starting right off with the curtain wall fire spread. There are two types of fire spread in a curtain wall. The first one is called as an internal spread of fire, where fire on one floor will spread to the floor above through the perimeter void. The second type of fire spread is called as a leapfrog effect, where fire on one floor will break the vision panel and spread through the exterior of your facade and enter the floor above by breaking the vision panel on top. Now, there are many architects here, I'm sure, and developers, and everyone loves zero spandrel constructions, right? Floor-to-floor glazing. So let's see what happens in a floor-to-floor glazing construction when there is no tested system that is implemented. So in a fire scenario, you would have a fire that is in an ignition phase and continues to a growth and a flashover after a fully developed phase. This would break your glazing panel open within roughly 20 to 25 minutes, because everything within the interior or the fabric of the building would contribute to the fire growth and development. And once your vision panel breaks, your fire is automatically onto your next floor, because you have absolutely no separation there to protect you for leapfrog. However, if you have a properly tested and certified solution that is there, with a spandrel panel system that is tested and certified for the same, then even when you have a fully developed flashover fire that is coming in place, your vision panel will still break. There's nothing you can stop that. However, it will not enter back into the floor above until at least 2 hours. Now this, obviously, you have to check with us what are the different spandrel heights that are present and what is the data that is available as well. However, if you have a proper solution, you have at least ample amount of time for the fire services to come and rescue the occupants of the building and to save adequate property. So what side rise offer as the primary product for curtain wall compartmentation is called as the perimeter barrier, which is the curtain wall fire stop. A perimeter barrier is basically the extension of the performance of your floor to the rear of your facade. If your floor is 2 hours fire rated, then the perimeter barrier should be 2 hours fire rated as well. It is extending the fire performance of your floor slab. There are 2 test standards which are there for testing perimeter barriers. The first one is an American ASTM E2307 test standard. This is also reflected within the KSA, the Saudi Building Code as well. The second one is an EN1364 Part 4. Side rise are the only manufacturer in the world to test for both these standards with non-fire rated aluminum curtain walls. It is imperative that the same cycle that, the same product that is tested for fire is also pre-tested for cyclic movement. Your building through the course of your life will go through different movements. So it is important that the perimeter barrier takes all those movements and then performs in a fire. So once the movement cycling test is done, then it proceeds to the fire testing. Now these are 2 images of ASTM E2307 test, which we've done in the UAE in Thomas Bell right this year. And well, you have 2 fire sources within the construction of ASTM E2307. The first is an internal room burner, which starts at the beginning of the test. And second, you have a window burner, which is ignited after 5 minutes of the test commences. Now let's assume you have a zero spandrel design and you only have this transom that is present. You can see after 30 minutes of the test, your transom is gone, your mullions are gone, your fire is already on the next floor. So it is impossible. But however, if you have a proper spandrel arrangement that is there, which will stop the fire from entering the next floor, then you have a tested and listed solution. So basically, your aluminum curtain wall, which is non-fire rated, loses its structural integrity at roughly 350 degrees Celsius. You need a proper solution to extend the fire performance of your floor to the rear of the facade. You also need a spandrel panel, which is tested and certified as well for the same application. And this, along with mullions, your mullions, which are your structural members, need to be protected along with this. So what are the advantages of side rise over a two-part or a sealant system? So I'm sure you guys are aware there are many two-part sealant system manufacturers that are present all the world, but side rise are the only one-part system that are present. And why we are successful in the market is because for a two-part system, there are multiple processes that need to be done. You need to cut the stone wool slab that you get. So first thing you need to verify, are you using a tested stone wool slab? Or are you using a generic off-the-shelf stone wool slab, which will not give you the fire performance? And you're compromising your safety already before even the installation begins. So are you using the tested slab? You cut it, you rotate it by 90 degrees, make sure the fibers are in the vertical orientation. You compress them as per the certification requirements. Now this varies. It could be 25%, 33%, 50%. It varies from manufacturer to manufacturer, and you have to pay attention to what you're utilizing. Then you install them, and then you have the sealant on top. The challenge is, everyone is prone to human error, and with this application, human error could cost you dearly. What we as side rise do is, in our factory, we already rotate the fibers and pre-compress them. So with that, we are taking out the human error factor. And with us, all you need to do is take an extra 10% of the joint width and insert a structural bracket to fix it back to the floor slab. And this would accommodate your movement and your fire performance as well, from one floor to the next. This was a mock-up we did in KSA last week, and well, it was successful. And another beauty about the side rise fire stop is you can install it anywhere along the thickness of the floor slab. And yes, we do have test data to substantiate that. Our fixing brackets can be exposed to fire, and we do have data for that as well. With that, I'll move on to external facade assemblies or cladding solutions. There have been a lot of fires in the world for cladding constructions. I'm sure everyone's aware of this as well. All the combustible cladding, all that has been the talk of the town recently. The video on the left is a fire that happened in Istanbul in Turkey called the Polar Tower in 2012. What happened was the entire cladding elevation burnt off. You can also see the falling debris that is falling, and all this generated a secondary fire on the ground floor as well. On the right, you have a building in APAC where the fire started on the ground floor, and you can see how quickly it's spreading up. In less than 2 minutes, the entire building was under fire. This does not even give you time for the occupants to escape or run away. You're trapped inside. Both of them had combustible cladding, but other than that, they also had a cavity behind them, which acted as a chimney for aiding the fire to propagate through the system as well. So what side rise came up with is to block this chimney and to stop this chimney effect from taking place, which is a major requirement for ventilation, is we came up with a solution which had an intumescent graphite strip on the leading edge of a mineral wool slab towards the rear of a panel, any cladding panel this could be. In the dry state, this would allow ventilation of air, moisture, rainwater to drain through, etc. But in a fire scenario, at a critical temperature designed by side rise, it would expand and close off the gap that is present for ventilation. In this scenario, the integrity of your system would be sealed. Now, the SBC does not really say locations where cavity barriers should be used in a project. However, as a good practice, and this is also mentioned within the approved document B code in the UK, you require cavity barriers at every floor horizontally, vertically at 20-meter centers and at X corners, at least at one corner, and around windows and doors. Now, it's very important to protect your windows because in a fire scenario, once the window breaks open, your cavity barriers would act as your first line of defense. How are intumescent cavity barriers tested? There is currently only one standard that is globally present, and that is called as the ASFP TGD19. It's currently being incorporated into an EN standard called 1364 Part 6, but it's still in the preliminary stage and it's not yet adopted 100%. I'm not going to go into the details of the test. However, if you want more details, please feel free to reach out to us. We have solutions for different fire resistance ratings for 30 minutes, 60, 90, 120, and we are the only manufacturer that has these different performance requirements as well. So if you have a specific performance requirement, feel free to reach out to us, and we are outside, and you can discuss more with us. So we are big advocates of system testing. We do a lot of large-scale system testing with different partners of ACP, solid aluminium, GRC, GRPs, etc. NFP 8285 is a test standard that is mentioned within the SBC as well, specifically for metal composite panels. And we have BS 8414, which is quite prevalent in Europe. Now, this is two images of a test which is done in UAE in Thomas Bell, right? There is only one difference. The test on the left failed. It did not have any cavity barriers. The test on the right passed. It had the side-rise cavity barriers. Now what happened was, once the first porcelain tile panel, porcelain tiles are non-combustible, by the way. So once the first porcelain tile, once it cracked and broke open and it fell, the fire entered the chimney. And fire entered the cavity and it caused a chimney. And it caused the substructure to collapse and all the cladding tiles fell. But on the second hand, on the second test, when they used the cavity barriers, even though the fire still entered the cavity, because of the cavity barriers expanding and doing its function, the chimney was not present and the test passed successfully. So as mentioned, we are big advocates of system testing. We've done with different types of manufacturers. Probably anyone you say, we've already have a test with them. So if you have any information for us, please you require for any specific cladding system type, reach out to us and we'll make sure that you have the adequate information. ACP, solid aluminium, GRC, GRP, stone, terracotta, porcelain, you name it, we have it. So just a summary before I go into our services. We basically have three solutions. One is curtain wall fire stop, which is tested to the local building codes and regulations to 2307. We also have the European testing to 1364 Part 4. Second is our open state cavity barrier, which is for ventilated facades. And we also have the test data to substantiate that. And we didn't touch upon non-ventilated cladding, but I know that this is quite well used in the Middle East as well. But it's the same product that we'll use in the curtain wall, which has vertically oriented fibers, which can take the movement of your cladding panel both horizontally and vertically as well. Side-rise are big advocates, again, of new product development. We were the first in the market to develop a dry-fit single-piece fire stop solution and to have adequate test data to back it up. We also were the first to develop a ventilated cavity barrier system in the market. Obviously, people have followed now, and there are other manufacturers as well in the market. We were also the first to provide a digital means of site inspection. Now, this was very beneficial during COVID when we physically couldn't visit site to do inspections. Anyone at site could basically just download a software or an app, and they could do an inspection and hand it over to us, and we would approve or reject or give comments based on the installation. We also have QR code based on our products, which once you scan, you can get the information, all the documents, relevance, installation instructions, etc. Last few slides, I promise you. I know you guys want to go out and get some food. All our test data is backed up with adequate certification. All the global certification bodies are our partners. Intertek, UL, Thomas Bell Wright, ESL, IFC, Warrington 5. We also have the SASO approvals. Why certification is important is because they make sure that what you are manufacturing and testing is what you're still supplying to the market even after the testing is done. So I could test something but supply something else to the market. So that's not how it should be done. Certification bodies ensure that there is a continuity in the process. Our materials and our factory are sampled every quarter, and they make sure what is tested is what is supplied to the site. We also have mock-up and installation training. As mentioned, we either do it ourselves or we have our local arm present here in Physico who will assist you with that. The site inspection app. Now, this was a game changer for us because this basically ensured that anyone in any position, whoever has a smartphone could do an inspection. They could just download the app, iOS or Apple Play Store or Android, and basically answer a few questions. And once they answer a few questions, well, anyone could cheat questions, right? But you can't cheat images. So that's where the app was a game changer. You had to attach images with each specific question, and we would review this and get back to you within 48 hours. So this was a side-rise technical engineer that would review this and get back to you. With that, I'm actually stopping ahead of time. Wow, thank you.
Thank you, Donel. By this, we end our first session, and I think we will have a 15-minute break, coffee break. Hello, and welcome to the second session. The audience is slowly taking their seats. While doing that, I'd like to announce Paulo Carvalho, EFSO's Commercial and Corporate Relation Director. Welcome,
Thank you very
and we
much.
are looking forward for your talk.
I'm looking forward for the presentation.
The floor is yours.
Thank you very much. So good morning, everyone. It's a pleasure to be here in Riyadh. So my name is Paulo Carvalho. I'm the Commercial and Corporate Director of EFSOS. And today I'll be delivering a presentation with the title, Saving Lives Through No Combustible Membranes. So I would like to start my presentation with a quote and I'll quote, architecture can't fully solve problems of the world, but it can make the difference. It can create spaces that nature and hell. It can be a refuge for those, indeed, it can save lives. This is a quote for Michael Murphy, and this will be the mottos of my presentation. So, in terms of presentation, I'll be delivering a presentation and I give an overview. I'll start with an overview about standard market, the approach of the different approach that we have in Ephesus, and then I go deeply in terms of what are our systems, what are the non-combustible solutions in terms of breather, a new solution that is a breakthrough in technology that is Proflex, that combines elongation with fire rated. I'll speak a little bit about AVCL systems and why we don't need to compromise. Then I'll end with some examples of projects in different parts of the world, mainly in the Middle East, also UK, and around of the globe. So the standard approach is an approach that is price-driven. It's approach of mass production, and it's approach that, in opposition to Ephesus, doesn't take in consideration the specific needs of the market. But this is a general approach. In Ephesus, we have a different mindset, that is a mindset of understanding each project, understand the need of each customer, understand the need of each market. So what we try to do, or what we do, is understand the capabilities in terms of technology, in terms of industry, understand the needs of the market and the needs of each customer, and deliver a solution that completely fulfills the requirements in terms of technical, in terms of fire, and in terms of each need. So when we are able to understand each customer and each project and each market, and if we know the technology that is available, and if we use this, then we are able to create add value. I brought some examples of fire, and some of you already know these examples, but these examples actually, they are new examples, and I'll keep bringing them until things will change. Unfortunately, we see these severe fires, and the problem continues. Actually, the problem is being aggravated. We see in this chart that for the last years, decades, we see a massive growth in terms of severe fires all over the world. It's not a situation that we have in the Middle East, particularly in the Middle East, or particularly in Europe or US, it's everywhere. In terms of regulations, the authorities, they issue new codes to try to avoid this problem. I brought an example of UAE, but in UK, the same. After the Greenfield problem, they issue new regulations in Europe. And the problem is not the regulation. The problem is that each agent of the market that is the power of decision should take the actions to guarantee that the regulations are fulfilled. And unfortunately, many situations that we see, and I see this currently in the market, this is not fulfilled because of misunderstanding of information, because of lack of information, because of interest, economical interest. And I think we should reflect about this, because we have the regulations, we have the knowledge, but still we have the same problems. So in Ephesus, we work deeply, especially the university consultants, manufacturers, laboratories, to develop and deliver solutions that save lives, that avoid these problems of fire, and at the same time, they are technical, answer the needs of each project. I would like to bring a video that is the opinion of some experts, and I would like that you please take some attention to what is their opinion.
If there is a product available then that has an improved fire performance and it gets to A2, A1, then we should use it. But I think we also have to have a wider consideration of the product, the product's performance and capabilities, and what the actual risk is. If we can make sure that those products at the beginning, they've got a compatibility between all the constituent parts, We've got certification, and there is some history of use, and they've done some weather testing. That will give us the confidence really to recommend those products.
To move everything into the limited combustibility bucket, if you like, is where we want to be. And that's not just for EPDM membranes or buttons,
for all the overall picture. Yeah.
Overall pictures, yeah. So that's where we should be going, ideally. That's where the industry should be heading towards.
Absolutely critical. In the UK, we suffer from extremes of climate, temperature, moisture in the air. All of our buildings are constantly, settling in foundation terms, or moving due to thermal expansion or contraction during the colder period. So the elasticity properties of EVPMs are really critical.
I think it's more than afraid. I'm really concerned that when we are approaching this building safety bill now, going to be implemented, on all of our projects. I think we all need to be accountable for the work we do, and that it really is going to be a eye opener for a lot of people who had shied away from responsible working, specifying correct products and also approving the correct products, on the details. So I think it's coming that, we all need to be accountable and, responsible in the way we work, and, not compromise on the, the quality over cost is, I think, right. should be the main concern. But yeah, it's frightening when it's coming.
In the grand scheme of things, life is immediate. In an instant, it has come and gone. Time has passed us by. Have we seized it? Life is urgent. It's important. We must care for it in revolutionary ways. Waiting for tomorrow is a waste of time. We will never reach it. It will always be a day away. The Earth is moving, the universe expanding. Why shouldn't we? Proflex FR, elongation, fire rated.
So actually this, I emphasize this because we develop a product that is unique in terms of solution of weatherproofing and in terms of fire-rated elasticity. Bringing a little bit of history, in the past there were fire-rated products, but they were missing the elongation. So this is a really breakthrough in terms of technology, and it's unique in the world. So we just develop a thing that is unique in the world, and we are proud of this. And we are happy to bring this to the market. This was presented in Dubai last March, but we had some things that are very important, that is mainly the accessories. So we are able to deliver a solution that is complete, airtightness, that is really strong in terms of technical, that is air and vapor tight. And there is another element that I think is very important, that we can have fire-rated solution and sustainable at the same time. So the compounds that we have in the product, they are not warm for environmental, and they are recyclable as well. So then because we have knowledge on the job site, we develop a white collar. Why in the job site? If you have in the details this white collar, you can completely understand if you have any misapplication or not, if you have the sealant properly applied. And this looks like a detail, a simple detail, but this detail comes from the job site, understanding that just something as having a different color will help to avoid problems. And then, of course, that as all our products and systems, we can completely customize. Here we see if you have movements, and this is a basic thing. If you have movements, of course, that you need some kind of solution that accommodate those movements. And so this is Proflex. So this is the big breakthrough, that is, you have elongation with fire rate at the same time. So we are able on this particular membrane to achieve class B that is almost an A as a membrane and as a system. So then we have the completely family. So we have the breather, we have the vapor, and we have the proflex. So we can build, we can provide support the facade with a complete building envelope system. I brought these examples here because I think it's really important. This is a basic information. I was speaking with some very knowledgeable people outside, and because of missing understanding in the market, there's a lot of wrongdoing. So it's a basic thing, but if we are in a cold climate, in the exterior, we should use a breather system. Why? Because we have hot inside, cold outside, and of course we should allow the moisture go out from the facade. So this is a basic principle. Unfortunately, in the highest end on top projects, I see a lot of mistakes. And I see using of, for instance, breather membranes in cold climates like here. So if we are in the Middle East, of course we should use a vapor membrane from the exterior. Why? Because you have hot outside, you have moisture, and you need to block. But I see the other way around here. And the only way that I understand this is or lack of knowledge, or someone plays with information and plays with very serious things, you know. So I brought this because I think we need to have these opportunities every time. It's like a missionary work that we need to say what is the basics that should be fulfilled. So if we are in the cold climate, we should use from the outside a breather membrane, allowing the moisture to go out. If we are in the hot climate, like the Middle East, we should use a vapor AVCL membrane from the outside. And of course, our vapor and our breather systems, they are fire rated, A1 as a product, they are A2 as a system, and then we have all the accessories to customize according with the project. Our systems are complete, test, approved, and installed. This is very important because it's not theoretical, it's practical. So we develop the solutions, we understand the market, we develop the solutions according with the need of the market, we test, we approve, and we have a lot of examples installed in different parts of the world. This is very important as well. Why? Because you need a system, you need a solution, not a product. So to have a solution or a product, you need the accessories, and you need that they are compatible between them. You need accessories to warranty the connection in the different elements of the building, concrete or aluminium, and you need to warranty that they are compatible between them. Another very important topic, the facade. When you have problems on the facade, is in the details. When you have penetrations, cables, pipes, fasteners, is where you have the problems. So we have designed specific solutions to seal these particular situations, as we can see here. And of course, we test on fire, we test on smoke, droplets. Here we have different kinds of testings. This is the testing under the AN 13501. So as I mentioned previously, we test the different solutions and the combinations, the membranes and the accessories. This is allow us to look to any kind of project in the Middle East, in Europe, in US, and customize, because the membranes are different kind of membranes with a different behaviors. They are compatible between them, and the accessories, they are compatible, so you can just understand, and if you have the knowledge, you just adapt the solution according with the climate and according with the need of this particular and specific project. Of course, we test permeability as well. And of course, we have the different markets that we approach, Middle East, Europe, US, we have the specific third-party certifications for those particular markets. Of course, and this is very important, this is what I'm saying. It's amazing when we have fantastic products, and it's amazing when you have a fantastic strategy, but if you don't have the reality, if you don't have the products applied, then you don't have nothing. So that's important. It's important to have the beginning, understanding and develop the right product. It's important the certification, but the most important is to have the experience of the installation. And we have able to do projects worldwide, iconic projects worldwide. So I don't, they are already ringing me the bell. So I just brought some examples. I didn't brought much. For instance, everyone knows it's Bacellar. In the recladding, we use a vapor membrane system. This was in Expo. I just bring this particular example because we needed to customize very well. It was a very demand because of the shape, the building. So we needed to customize a fire-rated solution that was a membrane with self-adhesive. It's a project that's ongoing in Dubai. They are using the vapor, and now they are using the Proflex, this new breakthrough product. This is a project from Zahadi, Central Block of Iraq. It was also very demanding, challenging, so we needed to customize the solution, and this is the normal thing. We work very close with architects' office, engineering office, and we work with them on the detailing. Just brought an example from UK. Again, a lot of customization and a lot of detailing. And I'm ending with the Riyadh metro station where it was being applied a fire-rated vapor control layer solution. So, as we see, we don't need to compromise. We can save lives. So, I'm not saying this in an arrogant way. We strongly believe in this. In our scope, we help to save lives because we develop a solution that is non-combustible. And we are proud of this. So we are, again, the one and only for our peace of mind. So we can have peace of mind. We have the solutions available. We have the regulations available. And going back to beginning of my presentation, I think we need to think in our responsibility because we are decision makers. People that is here, they are decision makers. So we should decide and we should help to save lives and use the right solutions. So thank you very much. I hope you liked my presentation. Thank you very much. It was a pleasure.
Thank you, Paulo. And I think if we have further question and information, we can find you at the booth. And allow me now to welcome Omar Ahmed from PIF. He's a project manager who's working on facades for important project in the kingdom. And I am all sure that we are all looking forward for his talk. The floor is yours.
It's okay, thank you. Hi everyone. My presentation will be not really technical presentation, not purely technical. Actually, it is, you can consider it as a snack presentation. Since I couldn't present my current project for time being, hopefully soon it would be disclosed and able to talk about its challenges and whatsoever. So I will talk generally about the facade engineer, what's the facade engineer doing, and a little bit about the ventilation, passive natural ventilation, with little sketches I have done, with assumption I'm thinking about. So usually, especially the Arabic speakers, suffering with the vocab facade. Facade in Arabic means corruption. So anyone out of this field, once you ask you in which field you are working, which engineering field, you tell him, I'm working in facade engineering. Directly in amazement reaction, he's asking you, corruption facade, corruption engineering? I'm directly telling them, what is facade engineering doing? So facade engineering, exactly what the dressmaker doing in whole the circle of the design or engineering, let's say. So the facade engineer and tailor, both of them aware about the precision measurement in early stages and during the installation. Both of them has to get accurate measurement for well-fitted garment of the body. The body could be a human, or concrete or steel. Both of them should be experts in material characteristics and performance, and also the aesthetic, also the attention, sorry, of the detail. The facade engineer also stitching the details, the surfaces, and aim to get a proper solution similarly to what the dressmaker or the tailor doing. Aesthetic consideration, both of them should be in touch with the trendy materials and trendy fashion to be aware about the recent trends going on either for the garments or for the buildings, architectural designs. Exactly how the facade engineer awares about the environmental factors, the climate variations, the environmental conditions, the tailor is awareing about this also. So both of them aware about the environmental and the climate variations to, at the end, deliver a proper garment or clothes for the building or the human. Client interaction, both of them should be in touch, direct interaction with the client to deliver their requirements and preference. Movement and flexibility, both of them aware about the movement of the building or of the human based on, depending on the function of this facade or clothes. Both of them are moving, building and the human. So both of them should consider accommodation, displacement, movement for different reasons and conditions. Also, weather resistance. Is it rainy? Is it hot, cold, winter, summer? Should be considered within selection of the material and stitching the details. Ventilation, also similarly, both of them should be aware about the purpose of this clothes or facade, the climate or the geographic location with seasonal variations for the clothes or for the facade itself. So they should design suitable clothes to be comfort for the wearer either the building or the human. Here from the ventilation, I want to talk a little bit about the ancient passive ventilation is experienced in the old civilizations. So they were utilizing the wind catcher, attracting the fresh air from higher level to the lower level at the occupants level, ground floor, to ensure natural ventilation, and especially in winter seasons, and ensuring a full circulations, pressure circulations to ensure or to draw the fresh air from the higher level. So it is utilized in the old ancients by this way. This technology actually was very effective to do this purpose of natural ventilation. Even in the new modern architecture, the architects was keen to utilize the same technology to make a partial ventilation, not really total ventilation or natural ventilation, it's partial ventilation using this ancient technology. So I was wondering how we can adapt this shaft effect or stack effect for the natural air ventilation and facades itself. Normally, once we need natural ventilation, we open the window, but it's in specific seasons, especially in case A, we cannot open the window maybe 2-3 months per yearly, and we have to consider if there is noise around, if there is dust outside. So there is many different restrictions to open the standard normal window and aim to get passive or natural ventilation. Sorry. There is research has been done by Arab, I think, during COVID time, regarding the noise I'm talking about, the restriction that maybe make restriction to open the windows, especially in the traffic cities, high noisy areas. So they have added, sorry, they have added an absorber foam. Which one is doing the point? Yes. Absorber foam inside the chamber of the windows, okay, closed by perforated aluminum sheets. This absorber, this window is closed now, sorry, again. This window is opened here as a parallel window. So once it's opened and the noisy field about 55 to 60 dB, it can filter the noise about 15 to 20 dB to be about 35 decibel. That, as there is a tolerance, of course, depends on the configurations and the noisy field. So this technology, which is developed by Arab consultants, ensure that the opening such windows could reduce the voice and making better comfort and voice insulation for such cases in the parallel windows. So I'm just an assumption, it needs development. How if we use this technology, which is developed by Arab in the facades, for example, in the spandrel areas, which ensure natural ventilation. It needs, of course, pressure circulation to draw the fresh air from the spandrel area or wherever this window is integrated in. This fresh air will go inside and coming in by the ceiling, and ensuring also sufficient comfort of sound insulation. What the pressure circulation I'm talking about, which can be done by a greenhouse, or let's say the stack effect at the top of the building, considering the factors or the criteria of heights to run that shaft effect or stack effect, which stack the air or help to draw the air from the facades and exhausted up by the upper greenhouse. During this research, I find out that Gensler architects with BH Engineering, which is Bureau Hubble, has developed very fantastic and sophisticated system aware about this technology. As you see upside, there is a greenhouse with a glass roof, can do this task by doing the stack effect at the top of the tower and drawing the fresh air from the double facade all around the building. Simply here, as we see, the double facade as designed by Gensler and engineered by Bureau Hubble, doing the circulation by the first skin of the facade, has a parallel window open out and draw the natural ventilation either by the ceiling or by the ventilation flap up and down of the second skin, doing circulation of the natural air ventilation, and it would be in certain specific seasons all over the year. Here is shown that the solar chimney stack effect draws fresh air up and exhausts through top of tower, while fresh air drawn through the double skin facade. Here's the section of the technology or the methodology they have utilized in their study. This is the double facade with air flap upside and downside, sliding door, normal sliding door in the inner skin. This is the outer skin with open out parallel window. So here I'm just assuming that if we use this technology, which is developed by Arab, which ensures a high level of sound insulation at this area to be considered here for the noisy areas and accessing sufficient volume of air, fresh air to inside, of course, by using the pressure circulation, which is circulating the process by the stack effect or the chimney effect. Okay, that's it. Thank you all. Thank you. Bye-bye.
Thank you, Omar. And allow me now to call in for Michelle Bacellar. Michelle is an architect and structural engineer, and she is going to talk about facade technology. Michelle, the floor is yours.
Thank you. Thank you. Good morning, everybody. Okay, today I'm going to be talking about a project that took a lot of my time over the last 3 years, and I'm sure everyone here is probably familiar with the Shebara Island Resort. So the Shebara Island is it's an island 45 minutes by boat from the west coast of Saudi Arabia. And the Shebara Resort was developed on this area. It's a completely off-grid resort. So the development incorporates its own solar farm that supplies the power for the whole development. It also incorporates a desalination plant, a solar-powered desalination plant that supplies the fresh water. Also has its own small recycling plant that minimizes the amount of waste that goes back to the mainland. It is a 73-key hyper-luxury resort. And these are some of the people, the main people that is being involved on the project, at least for the part, the scope that I'm going to be talking about. So the development is obviously Red Sea Global. The architecture firm was Killer Design from Dubai. The engineering team was Arcadis, Middle East. We were employed as the facade designer, and we also looked after the supervision of the fabrication as part of the engineering team. The structure steel for the pods and the stainless steel was built by Grandcraft. The glazing works was with Glassline and Thomas Bell Wright, which are here today as well. They done the thermal testing, which I'll be talking about. So this development is a horizontal type development. So it comes in the form of several individual assets that are spread over the island. We have amenity assets, which are the hotel lobby, the restaurant, the spa, fitness center, and the like. And the accommodation assets they consist of the beach villas and the overwater villas. This presentation today, I'm going to focus just on the design and the construction of a typical one-bedroom overwater villa. So I'll be talking about the facade and the construction design for this typical villa. So the design intent for the villa consists on minimizing the environmental footprint. So the villa cantilevers over the coral reef, and it's supported to the ground just on a minimum area on this column that we call, this column here that we call the neck. The shape of the villa, it's an ellipsoidal shape with some cut-out openings. So there's a cut-out around the terrace area, there's a cut-out for the entrance area, and at the roof there's a skylight and an access hatch. The design intent for the facade was to minimize the visual impact of the villa. So the design intent consisted of having a very reflective facade that could reflect the environment and merge with the environment, so the buildings becomes almost invisible. So for us as the facade designers, it was very, very important to find the correct facade system and the correct material that would be able to achieve this design intent. In the initial design stages of the project, the structural approach for the villa was to have a carbon reinforced polymer structure. So the whole shell would be made out of this CRP. So our job then was to look at ways of cladding the CRP to achieve the design intent. So we've looked at several different options. We looked at finishing for the CRP. We looked at gel coating, automotive coating. We looked at cladding with flat stainless steel small tiles. We looked at having long single curved tiles. We looked at having larger tiles that are double curved. And at the time of the design, this was, there was mock-ups produced for every single one of those options. But in the end, all those mock-ups were rejected by the architect because none of them achieved the design intent, which was to have a very shiny and a reflective, seamless shell. So at this stage, we started considering building this shell out of stainless steel panels welded together to create a completely seamless and reflective facade. So when we took the decision to go ahead with this approach, we started looking for precedent examples of similar constructions. So we're doing research, and obviously, you know, all the constructions that we found that followed this approach were more like artworks or non-habitable constructions. So we took this example, the Cloud9 or the beam in Chicago, and we started studying how this was built. So this beam, it was made out of 168 double curved stainless steel panels. They were 10 millimeter thickness, and they all have stiffeners at the back. They were welded together. There was over 700 meters worth of weld seaming. And once all the panels were welded together, they built a tent on site. And there was about a team of 24 workers polishing for just over 12 months, just over a year, to achieve this seamless appearance. So based on this example, we knew we had a really big challenge ahead of us because we had to achieve a similar design intent, however, on a much lighter construction and with a construction period much tighter. We started the design by looking at what would be the most efficient thickness for this shell. Generally, when we design facades, we design the thickness of the material to comply with the structural requirements. In this case, it was a little bit different because we had obviously the structural requirements, so you had to withstand the design loads, but also had to withstand the fabrication process, the double curving of the sheet, the welding, the grinding, the polishing, and there was one element that was really important on the design, which was the visual the aesthetics of the shell. So we needed to make sure that we had to limit the deflections on the shell, so the shell would not create visual distortions when reflecting the environment. For that, during the design, we've tested a number of different support conditions and shell thicknesses. And we've run analysis of these different conditions and the thermal loads. So we would apply the thermal loads to the model, and then we would export the deflected shape of the shell into a rendering software, and we would render this deflected shape with different backgrounds. So we tried first with a zebra background. So these ones, you can see the deflections are very apparent, especially over the top of the shell. But then we said, okay, maybe, you know, there's deformations there, obviously, but maybe they are acceptable if they are in the final design condition, which will reflect mostly, you know, the sky or the water below the villas. So then we've rendered that, and we, you know, after several tries, we found with the architect an acceptable deflected limitation for this design. Also, we were very lucky with the shape of the shell as well, because, you know, the flatter areas, which was the roof and the underbelly, they were the ones that tended to deflect more or have the biggest distortions. But those areas were reflecting either the sky or the water below, so the distortion was not very apparent. And the sides have inherited stiffness because of the shape and the curvature. So these areas had very little deformation, and those were the areas that we wanted to control the deformation because they reflect obviously the adjacent buildings and the landscape around. Also during the design, we've also ensured that all the connections of the shell to the structure were flexible. So when we ran the structural analysis, we had to make sure that all those connections were flexible because that also helped limiting the distortions on the external shell. So the shells, all the connections were fitted with Teflon pads that allowed sliding and a small compression. So in this way, the shell could expand and contract almost independently from the main structure, which allowed this shell to move without creating any deformations. Now, in terms of design, we're very happy that we tackle all the potential issues that could happen during construction, but obviously these were all theoretical studies, so we wanted to be more certain about the design. So we've specified a bunch of tests as well to be carried out. So, there was a lot of the standard tests, we specified impact tests, indentation tests, and scratch tests. For the facade, there was obviously air and water tests. We also exposed the stainless steel under accelerated weathering tests to see whether there was going to be any corrosion on the material. But for us, the most important thing to test was the behavior of this shell under temperature loading. On a normal facade design, or most facade designs, the facade system will consist of individual panels, and then those panels will have a joint around them. So under temperature, these panels can expand and contract without affecting the performance of the facade. But in our case, we didn't have panels, we didn't have joints. We have one single element where all the panels are welded together. So for us, it was really, really important to understand how this was going to behave under temperature, because obviously the variation of temperature here is something real. Even through the day, between day and night, you have a significant variation of temperature. So there was two main things we wanted to test or to check. Visual deformation under the temperature change, and also we wanted to ensure that this shell was not going to generate noises, because obviously this is a hyper luxury resort, so the last thing you want is this crackling noises when and that would only happen early morning or late afternoon, so that would not be nice for the guests. So we came up with we've developed a specific test regime that was developed for this project that was based on the AAMA standard, the thermocyclic test standard, but it was not really to check how the joints of the facade. It was mainly to check visual aspects and the acoustic. So we've worked with Thomas Bell-Wright on this test, and it was quite an enormous amount of work. Because there was a lot of conversations in the beginning to, do the test on a small sample, so we couldn't, so we could do just a normal chamber and a standard chamber. But for us, this is one element. This whole villa is one element. Everything is welded together. So for us, it was very important to test a full-scale villa, so we could understand exactly what would be the behavior of this villa. So the test was undertaken on the manufacturing facility in Grand Craft in Sharjah. They've built a chamber there that was 22 by 22 meters footprint by 9 meters high. The chamber was clad with insulated panels. This is some of the equipment that was used for the test. So there was a bunch of AC units that would be used to create the cold cycles. The inside of the chamber was fitted with around 500 infrared bulbs that would create the heating cycles. So the specification or the test was conducted over 3 days, and the temperature cycles were 5 to 85 degrees. So we ran 3 cycles, and the villa was completely closed with the facade. The temperature of the villa was kept during the entire duration of the test at 24 degrees. And the whole chamber was fitted out with cameras, so we could record any visual distortion of the shell during the test. Also, the chamber inside was painted with black lines, so it would be, if there was any visual distortion, would be easier to identify. And then inside the villa, it was fitted out with microphones that could record any generated noises during the test. And there was also vibration sensors positioned within the shell, so we could identify the source of the sound if there was any. So thankfully, the test was successful, which gave us, the design team, and also the client, great confidence of the robustness of the design. And I think I just want to mention, because I think Lars mentioned this morning about design budget and the client's commitment. I think this shows we're very lucky to work with this client, because this shows the client commitment to want to deliver a project, you know, the best of the project. So it was great that they went ahead with the testing, because it just gave everyone the confidence that we needed to go ahead. So just going back to some details of the design. So the shell is accessed for cleaning via a access hatch. So everything that went on the shell, you know, there was great concern of the architect all the time to not impact this seamless look. So the access hatch was custom designed to take the three-dimensional shape of the shell. So when it's closed, you can only see a very slight joint around them. The workers, they access via rope access, so there was anchorages as well on the shell. They all have covers that as well, it doesn't impact on the final aesthetic look. There's a skylight on the roof of the villas. This skylight, it was, we've positioned them in a way that we could use a single curved glass within the double curved shape of the shell. This enabled us to use a flat glass that was just cold bent into place. And obviously the use of the flat glass instead of a double curved glass that significantly, costs significantly less. The facade system at the terrace consisted of a minimum frame sliding window, which was curved with concealed track. Now, whoever is familiar with the systems know how important it is for the track to be 100% flat, because any inclination on the track, you can compromise the operation of the system. This was quite a challenge as well, designing that, because the strategy for the delivery of these shells was a completely off-site manufacturing strategy. So all those shells have been manufactured in Sharjah in the UAE, and they've been shipped to the final location. So we had to consider a number of different design conditions when looking at the glazing. So at the manufacturing facility, the shell was supported in 4 points on a temporary frame. So when the manufacture was over, this was moved then onto a barge, it's still on the temporary supports. When he arrived on site, this shell was unloaded onto the pile caps. And at this stage, then, the temporary supports were removed. So when the temporary supports were removed, there was a different supporting condition. So there was a little bit of a deflection on the whole villa. And then, obviously, during the operation, there's swimming pools on the external terrace. They're going to be filled, which is going to make the shell deflected even more. So all these different conditions have to be analyzed during the design of the glazing to make sure that the glazing could accommodate all this without any problems. So the glazing contractor had to develop a special head track to accommodate more movement than the standard system. Okay, so during the construction, when the project was awarded, you know, we were always concerned whether the contractor would be able to achieve the vision of the project. So they've, during tender even, they produced a bunch of samples, and, you know, these are some of the samples. This sample includes 2 welded lines, which are pretty much unnoticeable. So this was very good, everyone was happy with it, but, you know, I think the question was, you know, can this quality be achieved on a full shell? Because, you know, a small sample is relatively easy to achieve the quality. We know that the shells had these cutout areas. These cutout areas, the stainless steel around the cutout areas, they wrapped around So we knew this was going to be very tricky to manufacture. So we've requested the contractors to produce bigger samples, including all these more challenging areas. So the samples got bigger and bigger and bigger. And eventually everyone was satisfied that, you know, we could achieve the quality and we could achieve the design vision. And so for the production, this is how a typical one-bedroom villa was divided. So there was 4 types of panel, the top and bottom ones, and then the middle ones and the intermediate ones. So basically that meant that there was 4 types of molds that were created to build one shell. The method used for the double curving was stretch forming. So basically the mold was created using a 6-axis CNC machine out of MDF, and then the sheet was placed over this mold and stretched. There was a little bit of trial and error in the beginning because obviously there's a little bit of rebound of the sheet, but so some of the molds had to be adapted to overstretch to allow for the rebound. Once the sheets were double curved, they were cut using these laser cutting machines that could cut the 3D shape. Then there was custom designed machines to polish. So after it was double curved, they started the polishing of the sheets. Once the sheets were manufactured, they were delivered to the assembly area in Ahmaria in Sharjah. The sheets were placed together, welded, and polished, and polished, and polished, and polished. And then eventually, this was the first production mock-up villa. So when they presented the first mock-up villa to the client, they made sure that they put, you know, the water on the bottom, so it looked like the final design condition. And I think everyone was really impressed with the quality that was achieved. And I will just quickly go because I'm running out of time. So this is some images of the production facility in Sharjah. The villa was fitted out with a part of the glazing work, MEP, the swimming pool, and some of the internal works. The weight of the whole construction was about 115 tons. Once those villas were ready, they were wrapped and sealed and loaded on the back of a barge. So this is the manufacturing facility, the assembly facility in Sharjah. So it was, the location was specifically chosen for the project because it had access to the canal that had access to the ocean. So it facilitated the loading of the villas on the back of the barge. So then these villas was transported to site, 4 at a time on a barge. The trip took about 22 days. Once they got to site, they were loaded into a smaller barge, 1 at a time that could navigate the shallow waters, and then loaded into the final position. And this is just some more recent projects, so pictures of the development, which is due to open next year. So thank you very much.
Thank you, Michelle. I think we are all looking forward to have a visit to these Shell hotel units. Now allow me to welcome Stefan Kling, PSC and Commercial Director for Shuko Middle East. He has 22 years of professional experience in facade industry. Stefan, the floor is yours.
Thank you, Salwa. Assalamu alaikum. Good afternoon. Michelle, great presentation, and it's now difficult to start here because this is really an outstanding project, I think, which you get once in a lifetime or once in a decade. It's amazing, and yeah, congrats to this project if you see the pictures. So today I would like to talk a bit about the pre-construction services which we can offer you as a system supplier. So offerings we make, so a little bit advertisement for sure, but then also what is PCS about and what are the roles and the references. And here I just want to point out, yes, we as a system supplier are doing these kind of pre-construction services, technical analysis, supporting. However, we are not competing to facade consultants or architects, we support. So because facade is by far more than aluminum and glass. So it's by far more. So there we support with the industrial knowledge, and thank you to the architects, and with this brilliant project we just saw, and even Lars in his speech at the very first beginning mentioned some projects. The architects, they push us into a direction to develop by far more than the 1 by 1 meter window. So we have to adapt to this. We have to challenge ourselves. And remember the RMK project Lars mentioned before. I was there on site also during the kickoff meeting as a role in Chico. And it was amazing because you see the 7 meters, some panels 7 meters, some 6, or the most of them. You see the panels and you stay there. Wow, how this would work out. So that's very difficult. And yeah, thank you for challenging us here, I have to say. So coming back a little bit about Chico, who are we? So we are a system provider based in Germany for windows, doors, and facades, and by far more. So we call ourselves the founder of the industry. We have 70 plus years of experience, and to be exact, 72 years, so 1951. So the offerings we make, for sure, everything about the building skin, doors, windows, facade, panoramic design sliding doors, sometimes also curved, yeah, challenging. I have to mention this. And for sure, different kind of materials, aluminum, steel, UPVC, fabric materials. So all the parts we are offering. But also safety. Safety is an aspect in terms not only about the fire-rated, smoke-resistant, but also in terms of bulletproof, bomb blast. And if you talk about bomb blast, not only when you think about terrorism, but also about oil and gas industry, because there's a totally different blast than when you come with a bomb attack. So, and this is a speciality in it, even in the combination of bomb, bulletproof, burglar resistant. So all these kind of parts we propose. Building envelopes, so wrapping around the building. So I come later on to a project as a reference project. So building envelopes as a skylight, or starting as a facade parametric and then going into the skylight. Roles and responsibilities. So what is the client looking for? And we talked a lot about budgeting and other stuff, technicalities. So the client just wants to have a house, for example. So he wants that it's working out, that everything is working out, and he engaged an architect. He translates this into an architectural design. Fancy, and it's exactly how the client is looking for, or what the client is looking for. And then it comes to the budget. Lars pointed it out, Michelle pointed it out. So there are a lot of things coming up. So this is the budget. So how you bring this idea, this frame into the budget. So till now we call it value engineering. Lars mentioned this. Value engineering in the very front is really value engineering. But unfortunately, when it comes to post-tender, don't call it value engineering. With all due respect, it's cost cutting at the very end. And if you do the cost cutting, this is at the end what the clients get. And this is what we don't want. I think we can all agree here in the room, this we don't want to deliver to the client. He has an idea, and with all due respect to him, he invests a lot of money and he deserves by far more than this one. So without technical support, things become even dangerous. Yeah, so the function is not given, or even, Houston, we have a problem. Yeah, so the bridge is not matching. And I think this has to stop. Yeah. So, but what to expect from the PCS services, or better, what not? So, client has a dream, not about a fancy shell, but maybe a nice villa, a nice apartment in the seaside at the beach. Exactly, we want to have a sliding door with a zero threshold, slimline solutions at the nice beach. And he has an idea which is hard to achieve, 900 pascals water tightness. So then the 900 Pascal water tightness is still in the air. Yes, we have a system, a proper one, a proper lift and slide door, slimline, yeah, not absolutely there, but 100% we have it. And this is exactly the miscommunication, the misunderstanding. So the client has a perspective, he has something in mind. Yes, it can be translated, it can be matched, but there's a little gap in the communication. So what to expect now? It's about listen and connect. Listening to the client, listening to the facade consultant, listening to the architect, and connect. I mean, we all had this Teams meeting, we all have the emails during COVID especially, which worked out perfectly in this age, in this time, in this decade, but nothing about a face-to-face meeting, nothing about a kickoff meeting. Sit together, work together, sleeves up, and then just sketch it, yeah, and listen, connect, and then understand the intent. What is the architect looking for? So there are steps, because sometimes you go 2 steps before, okay, 1, 2, and then you go 3 steps back. This is a project, but you have always to follow the intent, the intention, and then you have to look where it has to be reached, where we can reach it, and then you provide a solution to support all stakeholders, the developer, the investor, the architect, the fabricator, for a successful project. This is exactly the intent. We all have a successful project. And then not only the project, then it comes to the product at the end of the day. So how can we support with the product? Omar mentioned before the tailor-made facade, and I like this presentation, because the tailor-made facade is exactly what he mentioned with the tailor. So you have the facade, it's your skin, it's your protection. Even it's a double skin, so you have this jacket and a t-shirt, double skin layer, or single one. Omar matched it. Yeah, so this is exactly the point. Or you have an existing product. Omar mentioned, for example, the parallel opening with this acoustic layer. Okay, there is already a product in the market, also as a tilt window, for example. So again, challenging, and then defining the product. So coming to this 1,400 square meter canopy courtyard with a shading feature. So this is a kind of horseshoe, I would say, boutique shopping mall in Dubai, where we got the request to come up with a proposal for the shading for the courtyard. So, and we said, that fits, because we just have a new product. It's a new system which gives you the parametric, the freedom, the versatility, the aluminum, the lightweight, the freedom of design, and the easy fabrication and easy installation at the very end of the day. And it's cost effective in comparison to the available knowledge in the market. So it's the so-called grid to shell, from the grid lines of the architect to the shell of the engineer. So the grid to shell. So the first process is to designing this, get the model of the architect, of the facade consultant, and translate this into our model for the structural calculation, so that we can model the nodes. Because the nodes, you see here, the blue one, these are the essential points in this design, because the nodes take over all the different angles, and each and every node is produced separately for each and every project. And then generating out of the 3D design the final product on the machining. And here we go one step further. It's also the support in the structural calculation. So structural calculation is here absolutely essential, because if you talk about a freeform facade, differences in the height can give you totally different structural members, sizes of the structural members. So here we are in touch, in connection with the consultant, with the architect. Can you agree to hire this 50 centi or 30 centi? Because then we can save money. But it's not all about money, it's also sustainability, because if we can downsize the aluminum, less weight, less aluminum, so we can save CO2 as well. So value engineering in the very first beginning is also about sustainability, not only in your pocket, but also for the environment. So the design itself, made of aluminum, so as mentioned, the node is the principal part here, is also the mullion. So the mullion is a butt joint, pretty easy to connect with the 2 screws. And then you have just an add-on gasket and a toggle system. So easy for the installation. And this is a node, as mentioned, milled on a CNC machine out of the 3D generating model. Then the aesthetics, aluminum versus steel. Because currently, if you think about these kind of skylights, these are steel skylights. So in the steel, you have a primary steel, you have a subframe, and then the aluminum part. And here in our system, everything is done via the aluminum in a high-strength alloy, in a perfection extrusion. Aesthetics. Steel versus aluminum. So aluminum you can powder coat, you have the coating part, no need for welding. I know that I took not that nice pictures from the steel, but this you get on site. This is, yeah, come on. You often get this on site. Just a random selection. Now, there are for sure companies outside who are perfect in this. Yeah, almost as nice as the villas. Exactly. But at the end of the day, this is a picture from the site. So this is the aluminum part. Very nice, beautiful. And for sure, as you are aware from Schüco, everything is tested. So the design wind load we had here is 4.5 kilonewton. And okay, it's a little bit small, but you can see it here. Also, the water tightness is 4.5 kilonewton. So normally, according to the specs, depending which specs, you say 20% of the design wind load should be your water tightness. Here it's 100%. So we stopped even. Because it's necessary. When we talk about facades, when we talk about skylights, and the seamless transition of a facade in a skylight, it should be watertight, airtight, whatever. So then we talk about the shading features. So we have a product, it's a so-called Façade, which can be implemented. Because I go one slide back, what you see here, the top, the courtyard is open. So normally you put glass in the normal shopping mall or whatsoever, but the owner wanted to have it in kind of open light. But however, he wanted also to have the shading part. Why? Because there are restaurants underneath, and at least he wants to have a certain shading. And the first design was in glass from the architect. And then we said, come on, we have this, you want to have these light features. Why not talking about kind of fabric? So we have a system, the Façade one, where you have exactly this fabric. So why not combining this, the grid-to-shell profile, with a Façade profile? So we come up with a tailor-made part, especially for this skylight. So all in this animation, all the parts you see over here are now done in the Façade solution. So coming from the animation of the architect to the final product on site. So this is the final product you get when it's planned through the facade consultant, through the architect, in conjunction with the industry, what is available. That's not only for the facades, for other parts as well, but this is a very nice example here. Aluminum, steel again. So steel, you have to have a platform for installation. Installation to take the weight. The aluminum part, the grid-to-shell, is self-supporting. So you can either install it on a platform, but not for the weight, just to have, let's say, the access. You can, like here on the scissor lift, you can have a cherry picker, whatever is possible, or you can pre-assemble. So pre-assemble on the site, partially, and then lift in with mobile cranes or the tower crane, and if these skylights are not that big, you can also produce the full skylight and install. And this is one of the biggest one with 15 tons, which you pre-assemble down, and which you lift then later on to the building. That's then from inside after settlement. And this is exactly the 1,400 square meter courtyard, pre-assembled also on the site, on the tree columns, fitted. And what you see here is the decking is just for the access, because we were not able to build in there a cherry picker or something else. It was not allowed during installation. And that's the final outcome. So it's very flexible if you have a kind of product like this. So you can imagine like this shopping mall. Currently, we are very proud and glad to be involved in one of the biggest in Jeddah, the Jaharat Mall. So where we have plus 25,000 square meter of skylights, currently under implementation. And what you see here is all aluminum, it's not steel. Facades, parametric facades, easy to solve. Buildings wrap around, starting as a facade, going over into a skylight. Self-supporting, only to the sides. You saw the tree columns on the ground of the courtyard, but here, for example, the tree columns just to transfer the loads to the sides. Courtyard we had, double skin facades, just as a design feature, and skywalks, also possible. So again, and just to repeat, again, the pre-construction services, the technical part is one, but also to giving then the right value engineering to then support further in the budgeting, so that we come up with the right budget for the owner, for the developer. And here, that's the support of the PCS from Schüco. Thank you very much.
Thank you very much, Stefan. Very interesting, challenging, and doable, more importantly.
Yes.
Allow me now to introduce Arne Emerson, partner at Morphosis with an experience of more than 27 years. Arne has worked on many projects, of which I name Peru Museum of Nature and the current US embassies in Lebanon and Riyadh. The floor is yours.
Can you hear me? Yeah? Hello, everyone. Nice to be here. Nice to see you. I know it's late in the day, so hopefully you're able to stay awake and listen. I've got some exciting products to show you. So Morphosis, we're an office located in Los Angeles. We've got about 100 people. We work globally. We have offices in Los Angeles, New York, Dubai, Seoul, Shanghai, and Lebanon. So we've been working globally for about the past 2.5 decades or so. Excuse me. So over the past 50 years, Morphosis has approached building and facade design as a process that seeks questions rather than answers, that embraces complexity in design, that utilizes the constraints and parameters to solve problems, and that leverages technology and collaboration with industry experts like all of you to influence design, fabrication, materiality, and craft. So our approach to design doesn't necessarily view construction as opposing forces. Oftentimes, some architects have a challenge with that, with construction and constructability. But we see it as a circular process, driven by a constant dialogue between yourselves, us, contractors, and industry experts. And the outcome ultimately is influenced by collaboration, intuition, exploration, discovery, and execution. We see facades as one of the most important elements of a building, combining performance, sustainability, durability, materiality, constructability with ultimately building identity and branding and image. And throughout the process, we use parametric modeling, and this technology allows us to explore generative ideas that allows us to give real-time feedback and a loop that informs our design. We use this modeling, scripting, and environmental analysis software to influence the design and early studying us, giving us real-time feedback. Combining that with our experience with 3D printing, CNC milling, mock-ups, and all of this to inform detailing, fabrication, and the constructability. And most importantly, we're assisted by all of you through the involvement in early process from fabrication and the construction industry, and all these experts to explore the possibilities of performance, materiality, and craftsmanship. So I'm going to take you through 3 case studies, Milan, Dallas, and Riyadh. Each one of these represents very unique climates, different characteristics, ones that require and demand site-specific responses to not only the building, but the facades themselves and the performance. So I'm going to start off in Milan. This is just right outside in Milan. This is the world headquarters for ENI. It's about an 80,000 square meter building on about 20 acres of a campus that just recently finished up. This project was really about kind of 3 things. It was about sustainability, performance, connecting to the community, and ultimately reimagining what a 21st century office campus could be. This was happening about 10 years ago or so. So we were really looking at this idea of open space, democratizing open space and really giving back to the people that work in these types of communities in these office buildings, and just more than an office building, but rather a campus. So we really looked at this notion of an Italian piazza. We put that right in the middle of the entire project, and then we put the buildings around the perimeter. And so that really started to inform the conversation as to how this building could not only provide a public space for the people that are working there, but then also reconnect back to the overall environment and the area that it's in. And so understanding how these kind of passive ideas of opening up, providing landscape, water, trees, natural ventilation, performance, things like that can really start to influence the design. So really kind of simply looking at the layout of these, and the performance characteristics started to drive this. So very simple ribbon buildings that are all defined by approximately 20 meters in width. And this was very simple because in Italian energy code, we have to balance the amount of daylight coming in with the height and the ceiling parameters. So very simple kind of economics with this. But ultimately, the 20-meter width drove the width of the building, which ultimately drove the access to daylight and everything else. And so furthermore, really looking at this an entire complex, understanding the solar, understanding the water and the air, and trying to combine all this together in a sustainable approach that really tries to combine performative aspects, looking at water aspects, how we can maintain that, how we can save that using cisterns, looking at air, natural ventilation. A lot of these things that oftentimes we don't see in the US, but oftentimes we see this as very strict energy codes and parameters for design that influences almost everything that we do. So when we start to look at the building, it starts to come alive in terms of its overall function, how it's working with the secondary skin, how it's working with the open spaces, how it's seamlessly integrating into its overall context, how it's starting to become a part of the urban fabric of just outside of Milan, breaking apart to allow wind, ventilation, sight, air, things like this to kind of come through inside the building. Meanwhile, also starting to respect the scale of the actual design itself, of the urban neighborhood, looking at the color, materials, the textures, and how all those can start to combine together to create this kind of overall complex for 4,000 people to use on a daily basis that becomes the new headquarters for this campus. And so when we talk about performative design, that's more than just facades, for example, right? That's just how people work, how they live, how they function, how they interact, how they communicate, and how the architecture that we create can ultimately support that. And as you've already seen with the facade design, it looks very interesting. Oftentimes with the facades, we try to use these, again, the constraints and the parameters. Any being an oil and gas company, we started looking at some of the geologic formations and excavations that they use. So they have these very beautiful drawings where they take slices through the earth where you can see sections of that. So we tried to use that as a loose inspiration for the facade design and the concept. So kind of taking this idea of excavation, earth, and oil, roughly representing the blue and the orange. So each one of these facades is made out of a PVD-coated stainless steel. It's 3 millimeters on both sides. It has an interference coating. And so on the orange facade, we have a series of components where these are these large-scale stainless steel panels that are attached to these stainless steel structure back behind with a catwalk. and then how it's put together with, back behind, we've got a curtain wall that's 60% open with 40% spandrel glass. So this all representing a very high performance facade that starts to work well, not only with the identity of the product itself, but then also with the performance characteristics and really meeting these strict energy codes for Italy. So in terms of how things are coming together, it's very, very much componentized. We worked with some fabrication experts early on to understand how this could go together, how they could install this, how they could prefabricate it in factories, ship it to the site. So really using those kind of collaborations with the industry experts that we worked with, some of the facade consultants, to really inform how not only this could be fabricated, but shipped, installed, and ultimately put on site. You start to see here some of the different views that I'm showing of how the orange and the blue facades are working together. You can start to see this layering and this transparency, and really how it's creating this overall building identity. So really kind of becoming much larger than the performance characteristics. And that's one of the things that's important in all the aspects of our work, is how can we really take the basic parameters, the constraints, the ideas, everything that it really needs to solve, all these performance requirements, how can we elevate that to something more than just something that's very static and something that looks like it meets code? How can we do something much more than that, that it actually becomes kind of a part of the community and much more iconic in terms of how it fits in to the overall aspect and also meets the requirements itself? So really trying to elevate and transcend the idea of what a facade can be to something much more than that. So looking at a lot of the different characteristics of this from the inside, this is a 50% perforated stainless steel. So when you look at this from the inside, looking out, you can see that's almost completely invisible. You can see some of the structure that's holding up, but ultimately something that's very transparent. It modulates light, it modulates the sun coming in, but then it also still gives views looking out for people that are working here on a daily basis. So as we had worked through construction and on site, obviously there were some things. How do we fold? How do we bend? How do we curve perforated stainless steel? Working back and forth with all the industry experts, often a lot of times like people with you, to really help inform our design and help inform how we can start to change and tweak our details in order to make this the best product possible in terms of execution and installation. And with all of our product, this is very common. Oftentimes we have a design idea, and just like Stefan was talking about from Schuko, we're architects. We're not always, we like to say we're builders, but ultimately we don't know how everything goes together. So we really rely on the expertise of all of the industry experts to really help us understand what's happening, what's going on, what's possible, and what's not possible. And sometimes we like that pushback. In fact, a lot of times we like that pushback, because that helps really inform what we need to do, where we want to go, and ultimately that starts to help with constructability, installation, cost, and schedule. It's an 84-meter spanning bridge that's about 4 to 5 stories tall that spans across there. So project we're really proud of. This took about 11 years from design to conception to completion. So something that will be coming out soon in some of the publications. So now I'm going to take you to Dallas, Texas. Dallas, very different than Milan, but also has a very harsh climate. They get temperature swings there that are varied. It gets very hot, very cold. It snows there. They have ice storms there. Sometimes they have tornadoes there. So a very different climate, a very different culture, but then also something that demanded a very site-specific response, not only for the building, but for the facade itself. The concept of this building is actually a cultural campus. So there's 2 museums, a performance hall, a big arts plaza, and a parking garage. Really, this project was all about community. It's on a university campus, so we really needed to understand how we can connect back to that. And ultimately, that has to do with open space. Buildings are important on campuses, but ultimately, the open space is more important. This was a large project with 2 surface parking lots that were there. It really didn't have a front or a back. It was really a site that was in the round, so we needed to respond on all sides. And it was something where we wanted to make more of the community aspect of it the heart of it. So we created a plaza in the middle and put the buildings to the side. And that really started to create this more kind of center of gravity for where the buildings could be oriented around that. So this is more of kind of a conceptual drawing, but essentially what it is, it's how we work and how we think. It's by taking those negative spaces, those kind of vectors where people walk, those walking paths, the pedestrian paths, et cetera. How can those vectors start to influence the actual building design? And you start to see here where you see the negative space is just as powerful as the positive space, the white being buildings and the kind of like hatched gray being negative spaces, and how that opens up. So really how exterior and interior start to connect with each other. Here you see an overall image of the model of this. You see the 3 buildings with the parking garage and this plaza that's in between. So really this kind of notion about community, right? So the site specificity of this, the cultural specificity of this design and how it ultimately engages with the university and solves the problems and the challenges for each one of these buildings specifically. So the first building is the one in front, the kind of like lower right. That's the museum that we're working on right now. It's under construction. So the design of this building, really the ground floor is quite simple. It's very compact and very efficient. And then once we get up to the second floor, our idea here, again, trying to respond to the overall climate, was how can we start to create exterior spaces, exterior rooms? How can we create a space with the building that starts to engage and embrace people coming to it? So instead of just walls coming straight down to the ground, how can we lift the building up? How can it start to embrace the people? So by creating a second floor that's larger than the first floor, we're able to do that by really opening it up. And you start to see in this section how the parking garage, the plaza, and how the building itself start to interact with each other. So this kind of lifting up of the building, creating this space underneath, was very much a kind of performance characteristic and a response of dealing with the site and the characteristics of the environment in Dallas. And so here we chose a precast concrete facade. We don't need as much glass. Museums and performance halls, cultural buildings, don't need to have glass like an office building. So we chose architectural precast. There's a great architectural precaster that's about an hour drive south of Dallas. It's cost effective, it's efficient, and it's something that we know well. And so we started working with them. We went to their factory. We understood how they work. We understood that it's about standardization. It's about panelization. So we created a pattern that's actually quite literally made only out of 3 separate panels and form liners, but then that can be translated and transcribed around the entire building to something that looks much more like a completely customized piece. But it was complex what we designed. So one of the things they were apprehensive about is like, how do we work with this? So we've got in-house technology. We have CNC machines. We have robotic arms. We have a lot of technology that we use to oftentimes build the mock-ups and proof of concept before we can show them. So we took a piece of high-density foam. We milled that out, flew it down to Dallas, delivered it to to the precaster, and said, here, pour off of this. Use this as your initial idea, because it was quite complex in terms of the patterning. They created a rubber mold off of that. They cast it off of that. And then they started looking at different ways that they could pour, and then we looked at a series of precast samples. So looking at, we wanted white to reflect the beautiful colors in the sky and the light of Texas. So looking at a white aggregate that was local, look at silica sand, look at different types of finishes and sandblasting that would really kind of bring out the characteristics and the uniqueness of this type of aggregate that's local to Texas. So really trying to embed this notion of site specificity within this whole idea of precast architectural concrete. So just a few images. It's under construction. I'm going to start with some renderings and then show where we are. It's going to be finished next year, but we're very excited about how this is really starting to take shape. Almost all the panels have been assembled and installed on site. They're looking quite beautiful. It's actually looking quite like the renderings, more so than we thought. You know, and really throughout this process, it was about us working with the overall our general contractor, the precast concrete fabricators, to really understand how can we make this a very cost-efficient building. As with most of our projects, we don't have the luxury of having carte blanche. We have very tight budgets, very tight schedules, so we've uncovered every design stone on this project probably 4 or 5 times, reiterated, revisited things, and how can we really try to use, I think Stefan earlier had mentioned, cost-cutting, value engineering. I agree that VE is really not about cost-cutting. It really should be about how can we bring value to the project. So every time they come back to us and say, we don't have enough money, we use that as an opportunity to redesign. Instead of just taking what's given to us, we actually go back to the drawing board and we understand, okay, how can we actually take this opportunity of cutting costs to make it better? That takes a lot more time and effort on our part, but ultimately it's something that we use to benefit all of our projects. And that's something where we really need to work with industry experts, and that's why we shine in the projects that we do, because we really then start to lean and leverage all of the industry experts that we're working with, especially with all the fabricators here. So early in the design process, we had curtain wall on board. We were using structural glass by Novum. We're using precast concrete. So all of these kind of unique facade materials that are actually somewhat unique to Texas in a way, it's something where we needed to involve people in order to help us. So by really leveraging that allowed us to completely kind of transform what this building could be and create something that's, you know, quite interesting. We've got curving precast here with facade panels on them. The precaster freaked out a little bit. It was a little bit too much for them, but once we worked with them, understood what we could do, putting patterns or not so many patterns on the curved panels, it really allowed us to create something that was really unique, but incredibly cost effective as we started to work with them throughout this process. So you start to see how the precast itself, this kind of undulating, this push-pull, this three-dimensionality of these panels is really quite interesting and unique in terms of how it's reflecting the light, the shade, the shadow, and the coloration of it. And as we near closer to the completion of this, we're excited about this in terms of how it's going to become a part of the overall cultural campus. It's always the most exciting part of a project when you just fly there and you get to see the actual things under construction and your ideas and everything that you've worked on. So it's really exciting for us to see these types of things come alive, and everything we do is kind of bespoke and one-off. So you never quite really know how it's going to look until it gets up there. And so this is one that we're really excited about in terms of how it's coming together. And so I'm going to end in Riyadh, another completely different other side of the world. But something that's also very unique in terms of its demands of the performance. As you all know, it's very hot here. I've been here many times over the past few years. I've been here in August when it's sweltering hot. And that very much informs how we design, how we think about things, how we think about the climate, how we think about the performance aspects, how do we fit into the culture, the region, how do we design a US embassy in Riyadh that embodies and represents the best of American values, because this is an American embassy, and one of the demands and requirements from the US is that they want this to be the best of American innovation. But how do you balance that with building in a host country, in Riyadh, for example, here in the diplomatic corridor? How do you balance that with security constraints that are extreme? How do you also do that by making sure that it connects with the environment, that it's something that's open and welcoming? So how do you create an embassy that really starts to synthesize all of these constraints and parameters together that looks like a beautiful building? It actually becomes a part of the community. It's integrated. It performs everything that a building needs to do, but something at a kind of much higher level. 1945, about 75 years ago, I think the relationship between the US and Saudi Arabia started with FDR and King Abdulaziz on the USS Quincy. I think he had never been out of Riyadh at the time, so they met and they kind of formed and forged a relationship right after World War II. So this is something that's kind of been an enduring legacy and something that we've used to inform a lot of the design and some of the aspects of community that we're looking at. So this project really kind of embodied three things: community, landscape, and performance. And really these kind of three ideas are what drove our entire design. So community, this is an embassy. There's a lot of Americans that live and work there. It's in the diplomatic corridor. There's a lot of other people that live here, a lot of people that come from around the region, from Riyadh, et cetera. So, you know, not only for the people that live and work here on a daily basis, but also the people that visit here, it's something about community. Oftentimes embassies, doesn't matter what country it's in, if it's in another country, this is a lot of times where the expats live. It's where they hang out. It's where they go to see other people, to just be a part of the community. So it's more than just a collection of buildings, it's really a campus. This happens to be on 30 acres, it's about 50 to 60,000 square meters, so quite large. So something that we really took this kind of to heart in terms of how we would use that as some of the design requirements. The landscape, as all of you know, and if you've been outside of Riyadh and just been in Saudi Arabia in general, some absolutely dramatic and beautiful landscapes that are here with the wadis and some of the different rock and geological formations, and just the colors and the textures of the desert are just, they're striking. They're like no other places you've seen on Earth, maybe the southwestern desert in the US, but it's much more dramatic here. So really kind of starting to use the landscape as a way to inform our design, and then ultimately performance. Again, talking about the harsh climates of Riyadh, the temperature swings. It's beautiful to be here at this time of the year. It's actually quite nice. You can dine outside, but 3 months ago you would have been here and it'd be completely different. So understanding how can the performance of the building itself start to inform not only the design, but also the identity, everything that I've been talking about earlier. And so, you know, we started out looking at regional qualities, and I think one of the gentlemen before was talking about natural ventilation and some of these kind of passive strategies about courtyards, landscaping, materiality. shading, coverage, just basic ideas that have nothing to do with design and engineering, really just has to do with how you used to build, how we used to build here. How can you use these very basic passive strategies to create shading, to create community, to create air ventilation. Looking at landscaping, looking at the different types of kind of indigenous landscaping and trees and plantings that's here. Looking at water, how can we start to use the landscaping as an inspiration? Same thing with the buildings, looking at the thick walls, the facades and things like that and the materiality. Like how can we start to kind of take those as an inspiration? And then backing all the way up and looking at the landscape as I was talking about from above, looking at the wadis, just looking at the kind of beautiful variegated landscapes here. And of course, Wadi Hanifa being one of the largest kind of identifying icons within all of Riyadh, spanning from north to south. Diplomatic Quarter being roughly in the kind of southern western portion of the city, and where our site is in fact right next to Wadi Hanifa, one of the kind of fingers. So that was very strong in terms of us wanting to use the Wadi as a flow, as an inspiration. So this idea of a site that's kind of really facing east-west, it's really great. We wanted to orient the buildings in an east-west direction that allowed them to be self-shading. Looking at these kind of flows, looking at wadis as a very basic idea for how do we orient the buildings, how do we locate them. And then of course we looked at rationalizing that, looking at those geometries, straightening those out. But then it's more than just a collection of buildings, it's a campus, and then really understanding the kind of culture here of how can we start to create these courtyards, how can we start to create these exterior rooms, these places where when you arrive, that it really starts to become a campus and something that has much more community and characteristic in the heart of it. And here you start to see the overall 27-acre campus. You start to see how it's really a combination of not only buildings, but open spaces and exterior spaces. And for us, the spaces in between the buildings are just as important as the buildings themselves. So when we talk about the performance characteristics of this, absolutely the building has to perform, but these exterior spaces are just as important. And this is where we put up a lot of attention to. And so we created a series of these exterior rooms or these courtyards that start to become these entry points for whether it's the ambassadors arriving, diplomats, whether you're going to get a visa or a passport, or whether it's just people that are working here every day, or just a community courtyard. Any of these types of courtyard rooms and these exteriors that we see in a lot of spaces here in Riyadh, that if it's done right, if it's designed right, with the right shading, with the right landscaping, with the right qualities, we can actually create really nice spaces year-round to be used. So we took landscaping really to heart, and in between these buildings, it really starts to fill in the canvas. It starts to kind of color between the lines and using landscaping not only as architecture, but a way to help cool, a way to help create characteristic environments, a way to really help spaces that are created much more for everyday use. And so here you start to see a kind of an overview of the campus in this more monolithic approach. And then we start to see this kind of from afar. And this whole notion here is that looking at how can we fit in, how can we be a part of this? So emerging from the site, emerging from the desert, emerging from the landscape. So it's not something that landed here, it's something that actually emerged from the landscape. So these kind of deep qualities of this colored stainless steel, using precast concrete, using stone, using landscaping, using really all these materials that start to really blend into the site and blend in and start to become an aspect of the overall campus. So these exterior courtyards that I was talking about. You see a series of louvers up above there. When we were designing this was during COVID, we hadn't really come here. We came here in August, it was 120 degrees Fahrenheit, I don't know what that is in Celsius, above 50, and we immediately came back and put these louvers up above. We really started to look at how can we start to be site-specific in terms of designing. How can we create as much shade, as much kind of outdoor spaces, so these spaces can be used all year round. They're not just formal spaces, they're actually utilized spaces. It's really a connection of the campus and of the exterior and interior. So these kind of formal courtyards that have landscaping, they start to combine airflow, water, people, etc. So they really become a kind of integral part of the overall campus itself. These community courtyards where people can use these all year round, day and night, on weekends, not only for business, but for informal activities, for events. This happens to be some of the very, very first entries. So when you're actually driving up to it and you're walking up, you don't see building first, you actually see landscape. So trying to use landscape as a buffer. So really not trying to use the building, but really setting the buildings back as far as we can to use landscaping and all of these to not only help shade, but become that kind of first soft approach to coming into an American embassy. Oftentimes building can be too opposing. They come right down on the ground. There's no thought between what happens when the building hits the ground versus how it integrates and combines with the landscape. So it's something that we're very sensitive to, how we can really start to utilize and combine these two together. This is a view down one of our main streets that becomes a kind of main thoroughfare for people. So we have the buildings coming tight together. The buildings are self-shading. You can start to see the facade that's starting to kind of work as a performative aspect, but then the landscaping that starts to fill in these kind of negative spaces. And of course, these passive cooling strategy that I've been talking about. This is absolutely not a new idea. It's not a new concept. People have been building like this for a very long time. But it's these types of ideas that we can start to import and utilize and deploy in each of our buildings, and especially here where it's very important. So looking at gardens, walkways, interior courtyards, and all these spaces, not only for the public, but for the private to utilize them, that really it's kind of free, right? If you design your buildings right, and if you do it well, these are all kind of free strategies that will really help make these much more equitable buildings and something that can be utilized throughout. And of course, this translates into a lot of daylit spaces. How can we actually capture north light, not south light? How can we capture indirect light to create these spaces that are light-filled? They're not hot. They're not heating up during the day. They're not necessarily utilizing more cooling to keep the building cool, but they're still keeping it light, reducing the overall electric energy that's used, and they're really trying to kind of make these a connection from the exterior into the interior. And so for the facades, this is something also where constructability, durability, craft, cost, all of these things came into play here. So really looking at the local colors, the textures, and the patterns of everything that we're seeing in Riyadh, in the region here, how can we start to utilize these to really kind of embed this as part of the community itself? And of course, the performative aspects. We all know, everyone's been talking about this today. Facades are one of the most critical aspects of a building. If you don't design it right, you can get it very wrong. These buildings can become energy hogs, they can become uncomfortable, but if you do it right, and with our secondary facades, this essentially also becomes a passive strategy for shading, not only to bounce a lot of the heat off, but then also to modulate the views and glare for people that are working inside all day. So these kind of performance aspects that allow even air to circulate and flow back behind to cool the building, not only to shade it. So looking at the overall component in the buildup, we've got the basic structure. We've got then on top of the catwalk, we have a fin structure that's there that supports this panel frame. This panel frame is quite simply, it's just folded pieces of metal of stainless steel, and we've got these panels that attach to that. So during the design, this was a design bid build process. We didn't actually have access to a lot of contractors, so we took it upon ourselves to actually pay to have a mock-up built. This was happened to be in Salt Lake City. It was a large mock-up. We looked at the materiality, the thickness, 3 mm. We looked at these different high-performance coatings as PVD to make sure that everything worked, to make sure the details worked, to make sure that these fabricators could actually fold these pieces, to make sure there's a proof of concept that actually tells us that, yes, we can actually build this. Because oftentimes, like I said, we're working with industry experts, but this procurement method didn't allow us to do that. So we had to take this upon ourselves and pay for this ourselves in order to make sure that once we gave the client our design, that we knew it could actually be built. Because once we handed it off, we didn't have as much control or leverage over that. So it did turn out to be that way. These are some of the mock-up photos, as I said. So something that it really was kind of worth doing, and again, working with some of our industry experts. And ultimately, a result that just started construction here not too long ago. Probably take 2 to 3 years, but something that we're very excited about as it starts to emerge from Riyadh and the culture, and something that stay tuned, and we will start to see this. So thank you all. I appreciate it. I hope that gives you an insight into who we are and what we do and how we design our facades and performance. Thank you.
Thank you, Arne. And we will take now an hour lunch break, so we will be back at 2:20. Thank you for our third session. Welcome back, everyone. I hope we are not sleepy after this delicious lunch, and we are excited for our third and last session. Just as a recap, our session will have four discussions and 1 panel at the end of the day, or at the end of the event. And by that panel, we will conclude our session 3, inshallah. For now, I would like to give the floor to Eddy Abu Khalil. Eddy is Constantino Regional Director for Middle East and India. So I welcome Eddy to the stage from HVAC, I think, and mechanical engineering, shifting into glass industry, I think, and special fabrication of Cosentino. I think you would have a lot to tell us about.
Thank you.
Thank you.
Hello, everyone. I'm Eddy Abou Khalil, Regional Director at Cosentino, and I'm the lucky one to have the first session straight after lunch. I'll do my best to keep everybody focused. Yeah. So, again, I said Cosentino, who we are. Cosentino is a global leader in the manufacturing and distribution of engineered surfaces. And when I say engineered surfaces, we have two main engineered surfaces. The first one we have developed in 1990, 33 years ago. It is what is commonly used and known in the market as quartz. We call it a hybrid mineral surface, which is our surface called silestone. That surface is used from for any application indoors, flooring, wall cladding, any kind of countertop application, so all kind of application indoor. Our second engineered surface is called Decton, which is the surface that we're going to discuss today in the facade topic. Decton has been launched in 2013, and it's a surface that is used for any type of application from indoor to outdoor. It can be a very simple countertop, and then it can finish on a very complicated facade. So before we dive into the ventilated facade topic, I would like to walk you through the timeline of cladding. Cladding is nothing new. It was observed in the early 1900s in Norway, used as a secondary skin for barns, obviously for weather effect. And then in 1952, the first skyscraper in Pittsburgh of 30 floors used that system for the building. In the 60s, research centers and institutes in Europe start studying and researching that principle, and in 1980, it was commonly used in Europe. And then finally, we launched that surface, Decton, that is suitable for this type of application. So if we dissect any typical build-up for ventilated facade, we always have obviously the wall of the building. On that wall, we fix our channels, the vertical channels. We definitely need some type of application. In this case, it's kind of a rock wool. Then we have the vertical channels, and this is where we hang our last layer of facade skin, any type of skin. Very simple build-up. How the system works? The system works basically on the air circulation. So because we have the gap between the end surface and the wall created by these channels and the substructure, we have something that is the so-called chimney effect. So the hot air passes from the bottom of the system and it goes all the way on the top of the system. The gaps between the pieces of the facade or the tiles of the facade that are very much needed, and many of the clients, and they don't like it because there's a gap. These gaps are needed to maintain the air balancing of the system as well. It can be reduced, but closing it to zero will disrupt the whole purpose of the ventilated facade system. And if we want to look at the benefits of such a system, obviously it has many benefits. So if we look at the aesthetic benefit, we can clad any building, and if let's say we want to restore a building that doesn't have or is not at the same level, adjusting the size of our substructure, we can level the whole facade. We can change the shape of the building, because at the end we are doing the shape with the substructure, and then we are hanging our panels on it. The ventilated facade system, it works with the elements of nature. It doesn't work against it. So it works as a protective skin for the building from the bad weather effect, because it leaves and it creates that gap between the last layer and the building wall. It helps through the ventilation system to eliminate humidity. It helps to remove moisture, obviously. It also acts to enhance the thermal efficiency and the acoustic efficiency of the building. And where we can use it, basically everywhere, in all type of projects, in new build or renovation projects, in brief. Now looking at our surface Dekton and how it can be used in such projects for facades. Dekton, why it's suitable for outdoor application. Dekton is a mix of 20 plus inorganic materials, so there's nothing chemical or organic in the surface. This means obviously the surface is non-combustible, right? It's very highly resistant to all types of natural effect, like abrasion, like UV, and I'm gonna go through it later in a bit. How the surface is made. The surface is made the same way natural stone is made. Natural stone is made in the core of the earth with high pressure and high temperature. This is the same way we do Dekton. Dekton, we do it in our factory in Spain with high pressure and high temperature, an oven of 200 meters, 1,200 degrees. And the key differentiator between Dekton and any other surface on the market from its category that sometimes is compared to porcelain is the pressure. We are unique in that we are the only one that presses the slabs on 25,000 tons. We have a patent for that, and we are 20% more than any other surface on the market. This gives the surface high flexural strengths, and obviously probably the highest in its category, which helps in such technical installation like facade. So as I said, the specifics of the surface, it is, from a design perspective, is infinite because we do the design on the surface. We supplied projects with a surface and a color that is only for this project, and we called it with the project name. We gave the surface to a developer, and we called the surface in the developer name. And nobody else can have this color because it was developed by the designers of the developer. So we can create uniqueness to every project. Instead of having only a portfolio of 60, 70 colors that are repeated everywhere, if your design team will come to us, or any developer design team or architect or consultant will tell us, I want a gray background with these kind of veins, and we can make it for them, and that will be for them and only for them. Consistent thickness, obviously the material comes in various thickness of 4 millimeter, 8 millimeter, 12 millimeter, 2 centimeter, and 3 centimeter to satisfy all type of application: flooring, wall cladding, furniture cladding, countertop, facade, landscaping, swimming pools, cladding, any type of installation. The slabs, they come in large format, 3.2 by 1.4 and 3.3 by 1.6. So imagine the size that we can have. We have done 12 buildings in Abu Dhabi, around 65,000 square meter of facade with 3-meter panels. Imagine how much we minimized the joints on that facade rather than going with the conventional 60 by 60 or 60 by 120 size that we see it mainly everywhere. Abrasion, scratch resistant. The coefficient of thermal expansion, which is very important for our region, is close to 0, is nothing. Definitely UV resistant. If you want your building to last for 100 years, it has to be Dekton. The stability of the color is the same, non-combustible surface. It doesn't absorb, is stain resistant, graffiti resistant. They come and they paint on your surface. You clean it with any type of chemical. There's no problem at all. And obviously, resistance to very high heat and very high or very low temperatures. As I said, slab size is large, 3.2, 1.4, or 3.3 by 1.6. These are the thicknesses that we can provide from the material. It's a very flat, consistent material of all these thicknesses, 4, 8, 12, 20, and 30. It is non-combustible. It is an A1 material, and obviously in the system, this is the result of the system A2S1D0. And we also have the NFPA 285 for our material tested with various systems. UV resistant, I'm not gonna spend more time on this. Color stability is exactly what I said. It's very important to mention that Dekton is a full body material. Let's not focus on the design first, let's focus on the full body material. Many porcelainic surfaces, if it's a 12 or 2 centimeter, the first 1.8 thickness of it is a certain material that is basically cheaper than the last layer on the surface. Then you have the best composition on that 2-3 millimeter left from the material. Dekton is like a carrot, is orange all the way in, from inside to outside. So it is the same mix of product on the whole thickness of the slab. So it's a full body material. Plus, the design, yes, is on the surface. Also, we have body decoration, so imitation of the surface design. However, we just came up with a full body vane that is very unique, again, in the porcelainic industry, or similar to Dekton, which we hopefully going to have in the market in Q1 next year. This is to give you an idea on the color range of the material. It can be veiny, it can be imitation of natural stone or inspiration from natural stone like Laurent or any other slabs. It could be industrial like concrete look or metal look, rusty look. So it can be any surface or any color and design of your choice. This is very important. You dream, we do it. No absorption of material, resistant to stains, to paint and everything. It has all the certification that you want and you need for your projects. Dekton is a surface, it's the only cradle to grave surface on the market because we offset all the CO2 emissions during the whole life cycle of the product. So it has all the certification that helps you with LEED certification. From a sustainability perspective, it's the same. It's a zero carbon footprint, as I said. And it's a recyclable surface. That's very important. Where it can be used, as I said, anywhere, in any weather, in any location, facing the sea, not facing the sea, in the mountain, anywhere, and any type of application, from a simple countertop to a very engineered facade. So today we are focusing on the ventilated facade system, not on the direct adhered, obviously. We are not bound or limited to any fixing system, but I just named a few because we don't develop the fixing system. We are only having the surface. This is the continuous groove where we have the groove on the thickness of the material. With this system, we have limitation, obviously, of size of the panel. We have the undercut anchor that the size, this is where we can go 3 meter, 3.2 meter by 1.4, where we have the anchors. Fissure are outside and they can also explain to you, and we can explain to you about, if you want more information about the undercut anchor system, where we have this anchor in the body of the material, where everything is locked. It doesn't come out because of the conical shape, how the material is drilled and how the screw opens and attached to the material, and then we just hang. So the moment you put your substructure, it's just a matter of hanging, plug and play, like a puzzle. The exposed anchoring, which is very cost-effective material, and we can have the clamps powder-coated with the same color, obviously, of the stone. Hidden anchoring, another type where we have continuous groove at the back of the material, and here we can go large size panel again. The pinhole, which everybody knows used to be used in all the natural stone installation, we can also use that for our material. And then the rivet system, where we have the rivets, which is very, I think, common system in fiber cement, where we have the rivets exposed on the stone. You might tell me we don't like to see it. We can do the first 2 floors or 3 floors with the undercut system, and then we can save the cost with the remaining of the floors to go rivet, because the rivet are also powder coated with the same color of the stone. So it's very difficult to perceive, especially on a higher level. Our service and our aim is not only to sell you the slab. We are not only slab manufacturer and slab producer where we just want to put the slab on your project and leave. We support you from the day you decide to dream about your project. We support in the design stage. We can even get involved to either minimize and benefit the project. There was a project where they were doing concrete columns on the facade. We said, why all this to be wasted on the concrete and to add more weight and everything? We made these shapes only with the stone, and obviously they saved, and the developer and everybody was very happy. So we support in that, we support in the color selection, we support in the facade layout, what is very, to enhance the wastage of the building and the material. We also pack it the way you want and send it to the project, obviously, and support during installation. To name a few of our projects, as I said in Abu Dhabi, this is our latest installation of last year, 12 buildings at Qaryat Al-Hind, a project by SDIC. The tallest tower in Africa, the Leonardo Hotel, was done by our material as well 3 years ago. Munich, London, I'm gonna just go quickly through this. My time is up in a bit. This is very important to mention. The tallest waterfall in the southern hemisphere is in Australia, was supposed to be granite. And again, because natural stone is a material that is alive and it can create mold with water and blah, 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 it was replaced by dectone because, again, we don't have any interaction with the material. It's not porous material. It doesn't absorb. There's no maintenance-free. And when I say maintenance-free, it's really maintenance-free. Very easy to clean with anything if needs to be cleaned. So it was replaced by dectone. And that's it. I'll be happy if you want us or you want more information from us. My team and I are outside on our stand. We have an office in Saudi Arabia now, and hopefully we can see you in our showroom that we will open very, very soon in Riyadh. Thank you so much.
Thank you, Eddy. Very interesting material, and I think is very helpful now that natural stone is being replaced for sustainable solution. Thank you very much. Allow me now to introduce Susanna Noureddine. Susanna is the director at WSP, responsible for facade engineering. I think Susanna has a lot of cool stuff to tell us, so I am very curious to know about them.
Thank you. Thanks. Great. So super excited to be here. I think that's my second Zak event in the region. So yeah, I'm Susanna. I'm heading the facade engineering department at WSP in Dubai. Been in the region for like 7 years. I have the Chico branding also on my CV, so I'm a little bit biased when it comes to that. And today I'm going to show you a little bit of what we are doing in the region, what my team is doing in the region, and yeah, I hope to get you a little bit excited about what's coming and what's going to get built in the next 2 years. So to give you a little bit of background about WSP, and it's also kind of linked to the projects we are doing and the projects we are getting, because WSP, as you know, we do have a lot of different branches with more than 70,000 people worldwide, or nearly 70,000 people worldwide. So with the size of the company also comes the size of the projects. So our facade engineering team in the region, I think, is the biggest within WSP, which I'm like very proud of to lead. And we are part of specialist services, so there's acoustics, there's fire life safety, and the big portion of it is facade engineering. So global expertise is pretty big in our company, and probably the biggest advantage in working for such a big entity, because we are sharing knowledge from all the way from Canada to Hong Kong and Australia. So resource sharing and knowledge sharing is one of our biggest expertise, I want to say. And just to give you like an insight about what we are doing at the moment in Saudi Arabia and Dubai, Neom Slope. I know everyone is probably in Neom, very excited for that project, where we do deal with different climate conditions. I think this is one of the most challenging at the moment to get the team to rethink about climate conditions, because we are talking about minus 10 degrees for like 3 to 4 months over the year. So that's a little bit tricky to find now the people in the Middle East with that experience. And Shusha Island is at the moment what we are doing with our with the architects in Spain. I think it's Bofil. We are collaborating with the Guggenheim Museum in Abu Dhabi at the moment, under construction. Quite challenging when it comes to the geometry. We all know what Frank Gehry is up to. And the Sheikh Zayed Museum, I think, is one of my most favorite buildings in the world by now. It's not done yet, but every time I go for a site visit, it's probably the most magnificent project I have been honored to work on. And then what I want to show you today is the project which probably got me speechless when they called me into the meeting room and asked me how to build that. So that's the MISC Science Museum here in Riyadh. And yeah, I just want to give you a little bit of insight in how we got that engineered. And I hope then in a year or two I can stand here again and show you how much fun it was to actually build that. So yeah, when they called me into the meeting room and asked me, how to build that, I kind of had to digest what I was looking at, and it was a design competition, obviously, with architects who have never worked in the region. So to bring them into a mindset where the Middle East is a little bit different than New York City. So our biggest challenge with that project is obviously materials, workmanship, and the construction knowledge, I want to say. And yeah, how we are going to build that. So for us, when we started to declutter the facade and to actually look in what are the different components, what are the different materials, we identified like 3 different parts. One of it is like the main frame, which is like a steel structure. We have already talked with our friends from Schuko about the grid to shell, but I think that was pretty quick off the table. The 3-dimensional glass pyramids, which are like which are a little bit glass, a little bit of solid material, and the cantilevering fins, which are the biggest challenge. Glass fins, which are cantilevering. I think initially they were cantilevering for 3 meters. We got them down to 1.5, and cantilevering in all different directions. So we tried to see what is available in the market to give the client or the developer a little bit of confidence that it is actually buildable. Started looking into different materials. What is the glass doing? What is the ceramic frit doing, the solid materials? And then, of course, all the fins. So, as I said, the fins are the biggest challenge, and the different materials. Architects, dealing with architects who don't know what they want, I think is the biggest struggle for every engineer. And we try to get them into something which is buildable in the Middle East. And of course, we wanted to give everything a little bit of justification and put the label of, yes, we are sustainable on it, and try to integrate a little bit of photovoltaic into it. So the material summary, all of that was like pretty quick off the table when we saw the price for it, when we saw the engineering to it, and we ended up going with polycarbonate. So all of the glass, which was cantilevering of the globe, ended up being polycarbonate now. And as I said, we decluttered it. We tried to give it like different components, and started then with the engineering. So the engineering for the main globe was a bit of a challenge because they all came with references, and we had the contractor already on board with references of big globes which are already built. But our biggest challenge was that like all the loads are like going into the primary structure of the slabs, because it's a science museum, it's a kids science museum, and to achieve what the architect wanted in cross-section was, I think, one of our longest discussion with the architects. We ended up with a steel structure. So after exhausting all the different options, because there you can see how the slabs are deflecting, and we kind of had to put in. We kind of had to put in expansion joint, which is not as pleasantly received by the architects, but this was like the only way for us to achieve the cross sections to deal with the movements of the primary structure and then the steel globe. And yeah, of course, the pyramids, we call them the pyramids, are the main architectural attraction plus the fins. So, which gave us like the biggest struggle in how are we going to fix the fins to the pyramids. I mean, it's basically nothing less than a balustrade in all different directions, a glass balustrade, but as it is like a kid science museum and you don't want to have overhanging glass pieces 2 meters into the landscape was quite a challenge for us to deal with. So we unitized all of that to give it like a little bit of construction efficiency and came up with some brackets because it's not just like the engineering or the facade and the architectural intent, it's also the access and maintenance of all of that. Right? So that's a nightmare for my building maintenance team at the moment, which I'll show you a bit of later. So we started doing some CFD analysis to see how the fins are reacting in the different conditions and the different heights and the different orientation of the fins. Because the architect, as it was a design competition, were quite random, and we had to justify all of the fins in front of the developer and giving it the existence and why they are where they are. So we did like some CFD analysis in terms of wind direction, and were able to identify like the main zones of where we had like the highest cladding pressure, which is like in that case like the red part on the top, where we were dealing with like 2.3 kPa cladding pressure. So based on that analysis, we ended up with like different wind zones and decluttered the panels, took one panel out of it. So this is now the pyramid with the different fin location to, based on the CFD analysis, to see like in which direction. So this fin pyramid is now replicating all of the different conditions we have on the globe with the different fin condition in all different directions. And based on that analysis, we ended up with a lot of fins which we relocated, as in we were able to reduce the cladding pressure, we were able to reduce the loads transferred into the primary structure and the material thickness by just simply relocating 35 or 40% of the fins in different directions of the main wind direction. And then these are then the fins. We ended up with a bunch of fins still trying to justify why they're there and what they're doing. And then we started applying fins everywhere to give it a little bit of shading devices, and to make sure that we do not overshade the building, because on the top, that's why I just like showing the top, because it's a skylight basically, and under it is like the big lobby with a gallery. So daylight was a big discussion, and the number of fins, obviously, and the location of the fins. So we made sure that they don't overshade each other, that they are standing in the right wind direction, and to optimize daylight with that. But plus, on top of all of that, we were able to reduce the number of fins and optimized and rationalized everything down to, I don't know how many we have right now, but it was mainly driven by kind of cost and justification and why do we actually have fins. So, and in terms of daylight analysis, we had our sustainability team and the architects to give us their architectural intent And again, you see here by all the iterations we were running, how we were able to manage glare and overshade and find the optimized daylight condition. And here you can see like how we don't have, the balance is like the green part, and glare is like a big issue because it's a kids science museum, and the gallery on the top with all of the glass was one of the primary location in the building. And yeah, as I said, the other main problem, or actually the biggest problem, is access and maintenance. How are we cleaning it? How are we replacing it? How are we maintaining like all the joints in between the panels? So our access and maintenance team is getting, I think, sleepless nights by now to access like all of the locations and to make sure it's safe. Oops. So what we did, we've identified all of the locations on the building where we need like hands-on access, where we need regular cleaning, and where we need eventually replacement, which is pretty much 90% of the building. But we have placed a lot of human-sized models where we had to make sure that even if we go for abseiling, which is in that case the only option we were left with, that wherever you are on the building that you can move around without injuring yourself and without breaking any of the panels. So by now you can see that these are the cantilevering fins, which are obstructing a lot, which are again engineered to take the loads, the impact loads of potentially someone standing on them or leaning against them. And yeah, we did the analysis all over to find eventually like some points where they walk around with to make sure that it's not a random access to the building, and how they would come down, like this safety part, and then to make sure that they actually do not injure themselves when they're like in between that canyon of the three-dimensional pyramid. So we did like the analysis. We made sure that an actual decent human-sized feet can get in between there, and without like breaking an ankle or getting injured. So we ended up with a pathway which is a little bit out of architectural intent. So the architects were not happy with that grid we created, so just for the abseilers to have something to lean against. And at the moment, we are running another analysis for the abseiling, for placing the fins if someone comes down, that they don't break it, that they don't injure themselves, that the wind is considered, the wind loads are considered, the shading is considered, and the daylight optimization is considered. So there are like at the moment, I think more than 10,000 iterations which are running around the globe for a couple of those fins, where hopefully and eventually in a couple of years when this is built, that we have made the best out of it and optimized it on like all. Mika is shaking his head. Yeah. So and then I hope in another 2 years I can come and show you how much fun it was to build it. We're at the moment doing some mock-ups and seeing what the polycarbonate is capable in doing to get that effect. Hopefully in another 2 years. Thank you.
Thank you very much, Susanna. I think that's the coolest structural drawing I've ever seen, with the foot study and analysis. Now we have Jan Scheers from Kuraray. Hello. I think you're getting ready. No worries, take your time. He has an experience with DuPont Glass Solutions before it is being acquired by Kurarai, and I think they have a lot of interesting information to tell us. So the floor is yours.
Thank you very much. Good afternoon, everybody. My name is Jan. I won't bother you with my last name because nobody can pronounce it good. I'm here to talk to you about two aspects in the glazing business where we can help you with our interlayers, namely the security aspect and the sound aspect of buildings. This is our mission. Kurarai is a Japanese multinational company. We are the leader in the architectural interlayer business, and we would like to help anybody involved in building and facade construction with all the different types of interlayers we have available to make you build an amazing project. This is the total product portfolio we have. We have the standard safety interlayer business. We have decorative colors, tints, and the opaque black and white. We have acoustic PVB, which I will elaborate a bit later on. We have structural and security, mainly driven by our Sentry Glass, which is meanwhile, after more than 20 years, a well-known product in the market. We have some specialized applications, you know, PVB for autoclave-free lamination. We have UV Extra Protect, which is blocking 100% of the UV radiation. We have the opposite side, natural UV, PVB and Sentry Glass, which is applicable for greenhouses, for instance, where we want the UV actually to pass through the glass and the interlayer for the plants to be able to survive within the building. We also are active in automotive, so we have a PVB which is used mainly in windshields for cars and also in roof lights for cars. And we have also 100% recycled PVB, which with the sustainability attention we have currently is becoming a very interesting product in the market. So first topic, security glazings. There's a few things which are going on in nature and in the world which require people to design security glazings. I will not mention all of them, but you know, hurricane, forced entry, flood barriers, blast resistance, burglar resistance, ballistic resistance glazing. A lot of those require specific glazings which you cannot achieve any protection with a single normal laminated safety glass or with a single tempered glass, for instance. Civil unrest and rioting. What is the challenge these days? People like to design bigger and bigger glasses. Means that, in any case, the glass is the weakest part of the whole facade. People would like to make the glass bigger. They also would like to minimize the frame. So what we need to do is we need to match the glass and the frame in order to have a security application that works actually against these kind of riots. So security hazards from man-made threats. This is not the natural stuff, but the things done by human beings. Forced entry and exit. You see the whole list. There's a lot of things going on where people actually are forced to design specific high security glazings in order for these kind of things not to happen, or at least protect the goods and the people inside of the building. Firearm attack. It's quite obviously for vehicles and also for architectural applications right now that according to the standards, specific glazings, sometimes very thick, need to be designed in order to protect people inside a vehicle or a building from attacks with firearms. And the last section, bomb blast and explosion. Unfortunately also attacks with bombs and explosions happen, and for this kind of application also we have the ability to design specific glazings that protect people and property from bomb blast attacks. So this is just a simple explanation of what exists in the glass business. We have a normal float annealed glass, which exists. We have a tempered glass, which is a higher security than a normal annealed glass because it breaks in very small fragments. And then the ultimate solution for safety glazing is a laminated glass. So typically we have 2 or more layers of glass with an interlayer in between. From us, PVB or Centriglass. There's a couple of other interlayers on the market as well. As an example, polycarbonate and polyurethane is used a lot in bullet-resistant glazing, but we have alternatives for these products in our portfolio. So in order to protect people from forced entry, there's 2 specific testings which can be done. You only test the glass on itself, or you test the total window system, meaning the glass and the framing at one. So there's European norms for both, and there's also American ASTM norms for both. This is an example of a jewelry cabinet, which is designed and protected with our interlayers. You will see the first one, if I show the video, is a single laminate with PVB, where it's fairly easy to make a hole and to get through to steal whatever is inside the cabinet. Then the second video will show you, already started now, will show you the Centriglass, which is a more stiff interlayer. So this is PVB. After a few hits, you can make a hole and you can get easily through. With the Centriglass, and we have a hard-coated PET, which is laminated on the inside of the cabinet. First of all, it's much more difficult to get through, and you see on the left top side, this PET, hard-coated PET, prevents any glass fragments from falling inside of the cabinet. So this guy can go on for quite a while, he will never get in. So bullet resistant, this is the European norm from BR1 to BR7. Here in Saudi, now people invented BR7 Plus, which really doesn't exist, but it's even a higher level than the BR7. So it's a sniper bullet rifle like this. So you can imagine the thickness of the glass, the higher you go in the security, the thicker the glass needs to be to prevent the bullet from passing through. So Spall Shield, as was applied in the security cabinet, is a hard-coated PET, which is laminated with a PVB on the inside of the glass. So it's used in bullet resistant on the inside of the glass of a vehicle, but also in architectural glazing it can be used. This is just showing you the threat levels from low to medium to high, and which BR standards are used in these 3 applications. What we wanted to do in testing is actually find out which material has by nature the best resistance against penetration of the bullet. So we made blocks of 10 centimeter of different materials. On the left-hand side you see a traditional PVB. The middle is our Centriglass, ionomer stiff resistant interlayer. On the right side as well, it's just 2 different types of Centriglass. So we shot the same bullet at the same speed and the same distance, and we also compared with the traditional polycarbonate, which is used since many years in bullet-resistant glazing. So you see the standard PVB, the bullet penetrated 75 millimeters, which means it's holding a bullet, but it's not, it's not the best material to be used in bullet-resistant glazing. Centriglass and Centriglass Extra perform much better because the bullet only penetrates 37 and 31 mm. 31 is similar to polycarbonate, which is actually since many years the standard material for bullet-resistant glazing. As you can see in this graph, comparing traditional PVB to our Centriglass, we can make roughly 20% thinner glass to have the same performance. And we also have 20% lighter glass, because the performance is better, the glass is thinner, and the weight is roughly 20% lower as well. Moving on to sound control, acoustic properties. Sound actually is a mechanical wave that propagates through a transmission medium such as glass, gas, I have to say. Sorry, I talked about glass too much. Such as gas, liquid, or solid. In human psychology and psychoacoustics, sound is the reception of sound waves and their perception by the brain. So sound and noise are two different things. I mean, for instance, if you play music very loud of a song you like, for you it's just sound, but for your neighbor who might not like the music, it's noise. So what happens and what will happen? These are just images of things that create a lot of noise. The UN has predicted that by 2050, 2/3 of the people will live in big cities. So you can imagine traffic noise, population increasing, and the straight lines of the buildings that reflect the sound makes it necessary to design glass that keeps the sound out of the building. So just to tell you, 1 decibel difference just is hardly noticeable. 3 dB, you can hear the difference. From 5 dB on, it's quite a big difference. So if you can reduce the sound by 5 dB with your glazing, you have a really big impact on the comfort inside of the building. And 10 dB difference actually is like doubling or halving the intensity of the sound. We have 2 different products. We have a monolayer acoustic and a multilayer acoustic. So what you can do, how you should design your glass to reduce the sound. You can increase the thickness of the glass, or you can use a normal standard PVB or an acoustic interlayer to reduce the sound. Again, same thing, we have 2 different products. This is an example of comparing monolithic glass and acoustic laminated glass. So you see on the left-hand side, for instance, monolithic 8mm glass gives you 32 dB sound reduction. If you use the same thickness but in lamination, so a 4+4 laminated with standard PVB, you have 35 dB reduction. If you use an acoustic interlayer, you have 37 dB. So coming back to what I said before, between 32 and 37, you have 5 dB difference, which is a huge difference. It will make a really big difference. The other examples are similar, but just different glass thicknesses. What I also want to say is we have a calculator on our website, which is accessible for everybody. It's called SoundLab AI, and on that application you can actually predict the sound reduction from your facade design. So you just have to enter some specifics like the glass thickness, the cavity, the interlayer type you're going to use, and then it predicts you, based on testing we did in the past, it predicts you what the actual sound reduction performance is going to be of that composition. Just coming back to what Lars Anders of Priedemann said in the beginning, it's very important for all these specific things associated with your project. It's very important. You design something, you want a specific material to be used, you want a certain quality. It's very important through the whole stage of the project that you end up at the end when the thing is built, that the actual designed and specified products are used. Otherwise, things like this might happen. So basically, we as an interlayer supplier, we want to assist you, we want to guide you to the right processing people, and we want to make sure that whatever you designed in your project is actually used when the project is finalized. You can go to the website, there's a lot of bulletins, a lot of information. We also have the table outside, so please come there, join us there. Whatever question you have regarding these applications or anything else, we are welcome to assist you with your project. And that's it, thank you very much.
Thank you, Jan. I think one can appreciate double glazing, especially, and laminated solutions, especially when you're nearby a huge construction site such as the city of Riyadh. So thank you very much. And now, with our last speaker before the panel discussion, I would like to introduce Mr. Olaf Conreur. He's a Global Construction and Strategy Director at Axalta with more than 20 years of experience in the coating industry. I think he has a lot to tell us about powder coating and the latest technologies.
Thank you very much.
Thank you.
So good afternoon, everyone. So yes, I'm very happy to be here, and indeed, I hope that you will learn more about our company and what we do. So my name is Olaf Conreur, like it was told. So I'm a Global Segment Strategy Director for construction. I'm working for Axalta. So the purpose of this presentation is to introduce you Axalta, to tell you what we are doing, but also how we can help you beautify and protect your buildings. I know many of you know Axalta, but also I'm aware that not all of you know it. Actually, it's a company, we are from DuPont. We were sold a few years ago, and I think everybody knows DuPont. Big company with a lot of history, and actually DuPont sold us, and we left with all that experience. So we are really a coating-focused company for a few years now. So we are a $4.4 billion company. We have about 12,000 employees, and we are present in 140 countries all over the world. Our headquarters is in the US, in Philadelphia, but we have also local or regional headquarters, like in Switzerland for the EMEA or Shanghai for Asia. In terms of factories, I mean, today we are really introducing you to the powder coating business. We have factories all over the world. We have several factories in Europe. We have also factories in China, in Asia. We have factories in the US, South America, Central America, Turkey, and of course we have one in the region, in Ras Al Khaimah, next to Dubai for the region. So we're quite big in terms of coatings. We do a lot of things. We have 3 segments: the mobility, the refinish, and the industrial one. So I, of course, will not spend too much time on the mobility one. But just be aware that if you have a car, the likelihood that the body of that car is being coated by Axalta is quite high. And the same if you crash or you scratch your car, the refinish business will take care of it, and it will be repaired by our coatings. And then we have the industrial ones, which is basically everything else. The building products that concern everything that's linked to wood coatings, the energy solutions that are linked to batteries and the protection of wires, fire retardants for all those batteries, casket if you like, and then we have the general industry, which is really the powder and liquid business for everything that is metal. But of course today we're talking more about architecture extrusion, for which we have liquid, but especially powder solutions. For residentials, for your buildings, for monumental constructions, everything that's linked to window frames, curtain walls, louvers, and we call this. We are very proud to say that we have a total approach to the market, and we are the only company in powder coatings in the world to have thermosettings powder and thermoplastic powder. The thermosetting that is mainly going to be used on aluminium, but you also use a lot of steel, for which you need corrosion protection. And actually we have one of the best products in the world, which we call thermoplastic. I will come back to that later. Of course, in terms of quality, I don't need to go to the details. Of course, we have all the quality code, and we are meeting all the standards in terms of durability, warranties of 25 years, and so on. What makes us also quite different is that we have a specification team in all places, but also in this region. We can help you architects, but fabricators, consultants, about choosing the right product for your project. Not only in terms of performance, but also in terms of finishes. We have thousands of colors, and depending on your project, we can really help you on that. What's also important, I met some people coming from the US, coming from China, even from Korea. I mean, if you have projects that are worldwide, involving companies a little bit from all over the places, we can coordinate this for you, because we have those specification people based in different regions of the world. In terms of product portfolio for the powder coatings, we have, it's quite classic. I wouldn't say that's different from what you usually find, but we have this standard product, the Alista AP, then we have the super durable, and then we have the ultra durable. The difference is really in terms of durability and the warranty that we give, up to 25, 30 years, depending on the project. We have, of course, the Ahmar 2603, 2604, and 2605, depending on the range you are choosing, or the Qualicoat 1, 2, or 3 for the Altheyab UD, but the 3 is not yet available. I mean, if you go for coatings, I mean, our advice is really for your buildings, for your window frames, curtain walls, to go for powder, for sure. I know some people still use liquid, but if you are talking about sustainability, there's no doubt that powder is the right choice. No solvents, no VOC, almost no reject of the painting, and none of those heavy metals that sometimes you still find, especially in some regions. What's also very interesting with powder, which you cannot get with liquid, is the lead points. I mean, probably most of you are using those to value your constructions. You can get up to 110 points. Actually, thanks to powder, you can get up to 8 points. So, which is quite good if you think of the investment that you need to do in powder versus the rest of the building, the rest of the cost of the building. So, having 8 points. If you're trying to reach something like gold or even platinum, getting 8 points is very important, and getting it with powder, with our products, is probably something worth investing in. When it comes to sustainability as well, I would say almost always promote the Alista SD, the super durable, and because of its weather resistance, also because of its color consistency, because the scratch resistance is extremely good, because also, and it's something that maybe some of you don't care too much, at least from a direct point of view, is that the way to apply our product, the energy that you put in curing the powder on the metal is much lower, or lower than what you traditionally find in the market. So from an energy saving point of view, from a CO2 emission, it's quite a good product as well. But what really differentiates our super durable from in the market is our scratch and mar resistance. I mean, you can compare to what you find in the market. We are really, really good. And when you're talking about buildings for which durability has to be 20, 30, 50, or maybe even more years, it's very important, right? So as I was saying, the scratch resistance is excellent, and that's important when you're handling or transporting your profiles. The color retention is also very good, much better than what Qualicoat requires. So here again, our range of LSI UD is really the product we promote for your projects because of its durability, but also because of its mechanical resistance and because of its color retention. I was mentioning, so what I was referring to, the LSI SD, those are our thermosetting powders, but then we have our thermoplastic powder for steel. And here we have a unique range, which is really a performant range of products, the thermoplastic, which will meet all your requirements in terms of corrosion protection, especially in this region where you can go easily to C5. We have solutions for you, and if you want, we have a specification team here present in the region who can advise you on what kind of product you could use to meet those specifications. Okay, so we have thermosetting and the thermoplastic. So even if you want to have the same color between the two, it's absolutely possible because we have both technologies. In terms of warranties, as I was saying, up to 25 years for the SD, the super durable. We warranty on the color, the shorking, the cracking, the gloss, and we warranty on the building. So that's also very important. And we work with approved applicators. So quality is very important. You don't want to apply, even though the powder is excellent, you still need a good applicator. So we only work with approved applicators. In terms of colors, it's a pity I cannot show it here, but we have plenty of catalogs at our booth. I mean, we have a few collections. The Iconica is our flagship collection. I mean, if you open that brochure, you will see beautiful colors like some kind of, look a bit like wood or rust or bronze or gold champagne, some metallics that look like a bit like lunar metallics. So it's a beautiful collection, and usually, especially architects or designers, because we also sell to designers in furniture, I mean, they really love it. So it's really a flagship collection. It's maybe not our best sellers, but when people go for it, I mean, they are amazed. Then we have the Supranatic collection. It's also a super durable product collection. So this range was developed probably to compete with the anodizing, the natural anodizing that you can find. The big advantage of powder versus anodizing is that the anodizing, I mean, it's not, for the environment, it's probably not the best. The color consistency is not always so good, even although people like to touch it. I mean, it's probably not something so stable. With the supraanodic, we came up with a solution that is durable, that's environmentally free, that is scratch resistance. So it's really a real good alternative to anodizing in the market. Okay. Then we have, I thought it was good to mention this, we have a brochure or a magazine that our specification team and our color team has been developed every year. They renew this magazine every year, and there you can find a lot of projects that we have had all over the world, where architects are talking about the project they were leading and why they choose some colors and not others. So it's quite interesting to read about that, and that magazine is available online or again at our booth. We have a lot of track records. I wasn't sure what to show today, but then I thought we will show projects all over the world. We have projects over here, but also in the US or in China. So here is a project we had in Philadelphia. It's a super durable. It's just a beautiful building when you see it. Some project that we made with GN Architects in China, again in Shanghai, with this more wood effect that you can get, and which gives really that premium effect to the building. Here again, something we did in Nashville in the US. Again, that wood effect, the building looks unbelievable. Another building. This project was done with SOM in Shanghai, if I remember well, and it's also a super durable. So again, and they didn't go for liquid, they really went for powder. Here's something in London, again, super durable. This is done by Jean Nouvel, and this project, the architect wanted to use 26 different colors. So we had to customize all the colors for him. But if you see the building in real life, it's a stunning building. And that one is a building in Belgium, also done with super durable. This is using one of the colors that was in the Iconica brochure. It's some kind of, they call it the celestial metallic. And that building also today is, you can see it, it looks just amazing. And here, a project we had in Dubai, the Intercontinental Hotel, maybe you've been there. Again, one of our projects that we made with in collaboration with architects, of course, and fabricators and applicators. Yeah. And then the final one, the Malaysian one, another good project we had a few years ago, and the colors of the building, it's just the same as it was 10 years ago. And that's about it. Thank you.
Very much, Olaf. And now for a different change in setup, let's say, we are to open for our panel discussion. Allow me to call in Haytham Ayoub, the moderator for the session. Haytham is a sustainable and energy expert at AESG. He is an expert with renewable energy, and I think he's gonna talk a lot about sustainable energy and rapid transformation.
So good afternoon, everyone. Just I'm gonna start introducing myself, and then later my panelists or my colleagues, they're gonna start introducing themselves. My name is Haytham Ayoub, and I'm a consulting manager at AESG. And actually what we do is simply we work with sustainability strategies, and we work on the carbon emissions and the mitigation of climate change and all of these fields. So we work basically with governmental and private sectors. And I call myself one of the lucky people to work in these fields, actually. So I will let my panelists introduce themselves. Rina, maybe you can start.
I'll go ahead. Good afternoon, everyone. I'm Rina Yamak, and I'm a principal facade consultant at Zutari Middle East.
Good afternoon. My name is Mohammed Bahsh. I am working in the Red Sea Global, and I have a PhD in sustainability and modeling energy building in hot climates.
Right, welcome everyone. So the topics that we choose to discuss about today is actually about sustainability and to see how it affects the Kingdom of Saudi Arabia and worldwide basically, but our focus is we're going to be talking about Saudi Arabia more specifically. And for me personally, when I just came at the beginning of this year to Saudi Arabia, it was very impressive for me to see the development and how is the country, they are progressing in a very stringent capabilities and targets to meet developments and to mix this economy, not to be fully dependency on oil. And so it is, as one of the world's largest producers of oil, that's very interesting to see, and also how it affects the constructions activities, how it affects on the infrastructures, on buildings, and of course on facade in general. Of course, this development or this mission, it has a lot of challenges, especially when we are talking about sustainability, when this region, the weather, the climate, the status maybe of the buildings, more mainly we're going to be talking about buildings and we're talking about facade today. So from your perspective, Gina, how do you see challenges or how this affects facade and design from your point of view?
Sure. We're at a time and in a market where the building engineering industry is pushing its limits to it's pushing the sustainability requirements and strategies limits, and in parallel we have to push also for the upgrade of the regulations of the local codes and standards whenever it comes to the sustainability and its application and implications on the building material, on the facade compliance and strategies that follows the design progress. The industry is pushing the limits for the sustainability to be applied, and this will enforce or will impact also the operation of the local codes and regulation. And we have to allow for this transitional period for the local codes and regulations to upgrade their operations, and this will require an elite resource, and it will require as well a big investment, financial investment, to be able to push towards a more, I would say, more sensible regulations that can communicate the future perspective that we are dealing with and the future engineering solution that we are dealing with. We saw today with Michelle and with Susanna that the facade designs that we are trying to tackle and solve are pushing us towards one of two ways: either being exposed to the global supply chain of the material selection of the facade, or sticking to the local material selection and the local supply chain with promoting the testing and promoting the innovation within this material. So yes, I believe that the biggest challenge when pushing towards a new limit in sustainability is the compliance with the local codes and regulation that needs to, by itself, to upgrade its operation to meet this futuristic design approach.
Of course, definitely that's the case. Regulations is one of the most important aspects. And how about you, Mohammed, from engineering perspective and construction, the same question. What kind of challenges do you face in your work normally?
This is a great question. Okay, actually we face a problem with the construction industry in terms of sustainability because there is no benchmark. In Saudi Arabia, there is no benchmark built to a low energy building and to meet the energy efficiency requirement in building. Okay, so it's difficult for us to convince the end users or the clients or even the designers to design something or to build something or to pay for something which they didn't use to construct it. So this is one of the major problems which we have. Second problem is the resistance to change. Okay, for example, one of the designers before he came and tell us, no, I'm not able to design this one. I need to build it as usual, or design it as usual. The third one, when we come to integrate the renewable energies to the existing infrastructure. it's difficult because the existing infrastructure is not able in many areas to be integrated together with renewable energy. So maybe we need to renovate it, or maybe we need to upgrade it. So this is the main three challenge which we face in the construction industry.
Exactly, yes. And just to follow up on your point, Mohammed, one of the issues that we usually face is benchmarking and the lack of availability sometimes of data if we want to compare or want to analyze current situations, or we want to compare, and that's one of the challenges, things that we face, and we provide this, and we try to maintain this figure.
Correct.
The second things that I would like to jump on, which is definitely the solutions, in terms of solutions. How can we provide, I'm sure that in the market that there are different available solutions to these challenges or these concerns. So from Façade point of view, what do you think, Reed, in your experience, solutions you can provide to the clients?
We're receiving a very ambitious and futuristic architectural designs and projects. We're receiving crazy renders approved and are promised to be constructed and built within very few years. And for this, we have to upgrade our tools, our engineering tools, to what the architects are using. So we know that the artificial intelligence, computational design, and other advanced technologies are heavily involved within the design studios nowadays. And for us, from an engineering perspective, we have to upgrade our tools equally to be able to communicate the same language with the architect, with the developer, and of course with the other assets and other parties on the project. So I believe the integration, the heavy integration of the advanced technologies within our industry is major now, and it's crucial to shape the new solutions or the new engineering solutions that we are putting on the table. The new technologies are implemented not only on the design stage. When you are thinking big while designing, you have to think bigger during the manufacturing, and you have to think even bigger while construction. So we are seeing that this advanced technologies is happening in a transitional manner between the design, manufacturing, and the delivery of the project on site. Exactly. And we can witness nowadays a lot of new brands, a lot of existing brands that they are promoting and upgrading their manufacturing tools, their constructability tools, to be able to communicate these design changes and these design challenges that are being imposed by the architect and eventually by the clients. Yeah, that's it.
Exactly, that's a very good point, Rina, I think. And also, just to add on this, I think digitalization and the digital platforms, it's one of the maybe could be like biggest challenges, or where it has to be implemented and how it would be implemented. So moving to you, Mohammed, from engineering and construction perspective, I'm sure there are different kind of solutions that you can you share some lights on this, please?
Yeah, sure. What we need to do, we need to make all the parties involved in the construction industry on the top of the curve. We need to introduce new standards, such as the passive house standard which is developed in Germany. And this has some strategies which we need to introduce to the construction parties, like building orientation, thermal bridges free. We need to consider window-to-wall ratio, use the material with low thermal conductivity. And even we need to maintain air tightness layer all around the building and the building envelope. We need to increase we need to use material with, we need to use triple glazed windows, and all this strategy we need to adopt it, and we need to introduce it to the people working in the construction industry.
Yeah, that's materials, I think, as we have seen also a lot of the presenters, they talked about different materials, different coatings, and how it can affect on the U values of the engineering building in general, and the facade and the building envelope. So the other points that we would like to discuss today is about the heritage of the buildings, which I think in Saudi Arabia is one of the biggest and the most important points. We see, and I think Gina and Mohammed, you've seen a lot of cases where the clients, they come and ask like how we can promote our buildings, how we can keep our heritage, and how we can at the same time be sustainable and how we can minimize our emissions. Like, is this building capable of or this heritage, or we are able to keep the same heritage for the same buildings, and at the same time we minimize our emissions, we minimize our energy consumptions. Rina, I'm sure from Façade point of view you have seen many cases, and so what do you think? Do you think providing a sustainable building and modern building, we are compromising our heritage and historical buildings?
We've been involved with several projects in the Kingdom of Saudi Arabia where the stress point was to preserve the authenticity of the project. Say, for instance, the Daraya development. I believe most of the facade consultants have been involved in this project, and we were feeling the importance of the historical preservation of the richness of this Najdi architecture, and the client wanted to reflect this into the design process, the material used in the construction, specifically on the facade, and the constructability of this material. The challenges that we were facing is that the integration that was happening in between the authentic material, the Adobe construction, and other measures whenever it comes to the Najdi architecture, and its interface with the modern construction measures, with the concrete, with the steel, and any other material that is integrated within the facade system. So that was a challenge, and it was facing us it was putting us in a situation where we need to start testing, and we need to start testing if this authentic material can actually withstand the facade durability that we are expecting from a modern material. Add on this the sustainability layer. When it comes to the authentic, and when it comes to dealing with authentic and Najdi or any other earth material, it is a very sustainable material. We are not, the carbon emission is very low. We are using a very vernacular application. However, when it comes to the durability and the longevity of the design, we had big question mark, and this is where the testing and the testing of the system was in place. So whenever we're dealing with heritage, is crucial to understand that we have, as designers and engineers, always preserving the idea of reflecting the authenticity of the country and the authenticity of the location of this project. However, we always be mindful that there are other modern needs of an engineering that needs to be addressed within the same building. An authentic building doesn't need to compromise on the sustainability requirements. It will face challenges. We will be facing challenges in its application, but it's doable and solvable. However, we just need to put it into testing, and we have to put it into more, I would say we need to just think out of the box whenever we're dealing with such a construction typology.
Yeah, that's very interesting. Just to follow up on this, Rina, is there you talked about testing, and is there simulation that we can do that can withstand this material if we want to simulate this material?
It depends on the construction material. It depends what material you are dealing with. For example, for instance, what I was giving as an example in Daraya, the Adobe and the Adobe bricks and the Adobe render that we were dealing with, we had to put it into live testing and not only a simulation. Simulation programs can help a lot as well when testing the energy efficiency of the building, when testing how the holistic design of the facade is working within the building and the MEP system, the structural system, and so on. However, when it comes specifically to the cladding materials, some cladding materials and other, live testings are crucial. Live testing are important to be done on site and witnessed by the engineers, the client, and also the authorities. Again, going back to the local codes and requirements, for the fact that we are dealing with a lot of developments in the Kingdom of Saudi Arabia, we're dealing with with various projects with different visions. Going back to the local codes and standards, we can see some gaps not addressing the engineering solutions that we are trying to propose. And with that, we need to withstand to the international codes and standards, which might not be as coherent as the local requirements. So it's a chain. I think we are in a stage or at a time where we are all exposed to new solutions and testing new solutions that will be a base, or it will create a solid foundation to build or to build innovation for futuristic design.
That's, yeah, and you came back to the first point, basically, Rina, which is the codes and regulations, and we understand this point of view. Back to you, Mohammed, from your perspective, how we can do what we can do in terms of heritage, or how we can, from engineering perspective, how we can preserve or how we can keep this?
Okay, let's talk about how to increase the lifespan of historical building. Okay, first of all, we need to perform thermal assessment on the thermal performance of the building, okay, to cover and find out where is the gaps, okay, and come up with a report showing where we need to work and what is our plan to cover these gaps, okay. But mainly is the same approach which we are using for new building, we are using also for the historical building and old building, and it's mainly working with the reduction of the thermal bridges, improve the thermal insulation, and air tightness as well, okay, using triple glazed window, we can change the windows to triple glazed windows, okay, and we can also use new ventilation methods like the passive house, which is mechanical ventilation with heat recovery system, okay, and also we can integrate some renewable energy, which can reduce the energy consumption of the building.
Yes, and talking about what do you think, which kind of energy sources you think it could be effective, or mainly
Mainly we're talking here for solar energy.
Of course.
This is the one which is almost popular here in
yeah, that's really nice. And maybe to conclude from this panel today, I was having a chat with the panelists today, and we were discussing like how we can, or our daily routine at work, or maybe dealing with a client or with the team, or in general, how, from your perspective, how we can enforce this sustainable development, or what do you think from your point of view and from your, as a message from your side, what do you think, Rina?
It's crucial, it's important. We are at a time where sustainability is mandatory now, it's not a choice. So we have to tackle it in our designs from the very early stages. We have to take it into consideration whenever it comes into facade designs. Whenever we are dealing with the palette of the material, the selection of the material palette that we are dealing with, we cannot keep referring to the old school material palette. We have to upgrade this. We have to look into, to stretch more on the innovation that can happen on the facade systems. Maybe an additional layer, maybe, I'm not sure, going back a bit to the authentic solutions and implement it into the modern buildings. So of course it's crucial, it's important, and I believe that we are at a time where it's okay to test, it's okay to experience. We are having dedicated clients. Our clients are willing to test. Our clients are willing to put the project and the elements of these designs into test to ensure the viability of the solutions that we are proposing. I think we are at the golden age in this market to push towards more sustainable solutions and to push more towards more innovative solutions.
Innovative solution, that's very good. And what about you, Mohammed? What are things that you think they are important or related, or what you can contribute yourself to sustainability from your perspective?
We need to increase the social awareness within the public. Okay, because the residential sector is a very big sector. It's not only about BF project or big project or giga project. No, we have a residential sector which consumes too much energy and also producing too much carbon emissions. So we have to concentrate on this one. We have to increase the social awareness. We have to give them loans. We have to give them, for example, low taxes or awards or certificate. We have to encourage the people to go with sustainability and with energy efficiency in building. This
That's
is
very good.
important.
Yes. To conclude on this, maybe I would just share from my experience, you know, like with dealing with my teams and dealing with with my colleagues, one of the things that we really encourage, and we had this chat also about it the other day with the panelists, that it is how we can increase the skills within the workplace, how we can increase this knowledge, which partially also applies to what you mentioned, Mohammed, which is awareness and raising awareness in the market. And one of the things that we were looking at, or we were talking about, is reverse knowledge or reverse team leading. It's when we have someone new in the team, he can have more update knowledge about, especially when we're talking about sustainability or we're talking about the new technologies, where we can learn from them or we can let them lead on the terms of technicalities and lead them to share their knowledge. At the same time, how we can manage this, or we can lead them or guide them in terms of their journey. I know, Rina, you have maybe something to
Yes,
add
I
on.
believe it's a very interesting subject because we're dealing with this subject on a day-to-day basis in our lives and at our workplace. We all have different generations within our workplace, and I believe it's crucial to start promoting, to bridge this gap between the golden age of engineering with the new technological bright minds that we are facing at the moment. We have very young people dealing with computational design, dealing with artificial intelligence, dealing with tools that can be scary with their results if they are not well oriented and directed by some strategy-minded people, with some people who've been in the market providing engineering solution for years and years. Yes, they have the knowledge, yes, they have the understanding and the problem-solving strategies. It needs to be implemented within these advanced technologies. It needs to be oriented within this new generation who's playing with these tools with maybe without any direction can be really, really dangerous later on. So yes, I always like to tackle the subject that bridging the gap between the old and the new generation within the workplace, it's very important, and it comes not only by the mentoring or by orienting these people and putting them in one room together. No, actually putting them into test, put this old generation to test these tools, put hands-on, and vice versa. So yeah, I think it's a very interesting subject to touch on.
That's very good. So that was the main points that we wanted to present today through this panel. Any question, any comments by the participants? Anyone would like to share something, to share an experience, to highlight?
السلام عليكم.
عليكم السلام.
أسعد الله مساكم جميعا. One of the most question, all the time we are speaking about the big project. How we can develop, how we can coordinate, how we can connect the big project by the environment. Nobody speak about the small project. Let us say speaking about villas, palace. This is more than 70% from the project on the market. As we are working more than 20 years in the market, 70% from the project, it's from the small project, small and medium project. But all the time we are focusing how to increase the standard, blah, blah, blah. Even the government rules, all the time they are coordinating and they controlling the big project. But for the small project and the market, small market, that it's supporting this kind of project, nobody is looking for that. Even, I need to be honest, the role in the governments, they are not taking care about the small project, how to check it. Also, the producer and also the companies that they are supporting this system. Normally, even if you need to use this system, high quality or high sustainability, blah, 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 on the small project, the price until now, it's not compatible with the cost of the project. So it's need to do a new solution. If you see here in the United States, they put like a standard even for the small project. Maybe they do it as a standard size for the some of the windows, blah, 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 so they can increase the specification, and it's coming easy for the end user. That's it.
That's it. It's working. Well, that's a very good point, actually. I was, one of my clients, I was having this today, actually, this morning, and one of the points that we were discussing, we were talking about district cooling in terms of, from infrastructure point of view. And one of the question was like, why medium or low to mid-size buildings, for example, they are ignored in terms of the regulations? Why always the regulators and the developers, they always focus and they put the effort on only big scale projects, which is, I think, one of the answers it could be, which is related to how much investment and return it can bring to them. But I will leave, I think, Mohammed, he can answer on this question. He can share with us.
I totally agree with you. As I said at the last question, okay, the residential building and the small residential building, they're responsible about big amount of energy consumption and also carbon emissions as well. Okay, we need to raise the awareness. We need to speak to the public. We need to adopt some new strategies and standards like the passive house standard, which is mainly used for the low energy, for the standalone villas, as you just mentioned.
You know, Engineer Mohammed, why I told you that? Because if we did not increase the specification and the rules and a lot of things on the small, because the small project and the medium project, it will affect the people. Now, how many people will live on the big project? They are less than 5% from the people. If you have 30 million in Kingdom of Saudi Arabia, around maybe 25, maybe 28 million, they are living in a villa. They are not living on the big project. That's why I told you there must be role. There must be also all the fabricator, like Shuko, like all our partner. They have to develop a system. It can be able to manufacturing, plus also the company who's manufacturing the glass, the company who's manufacturing all these things. That it can be. In the end of the day, there is product with a good price, because the price now is playing very, very, very strong in the market.
Yeah. I would like to add on this one. So I think this can be addressed with main 3 points. First, it comes again to the point of upgrading the local codes and regulation. We've been into the Saudi building code, the UAE building code, and we always get within our design solutions that, oh, it can comply or it cannot, and then a lot of times we put a step back because it cannot comply. So first thing first is the local codes and regulation. Yes, the focus should be put together. Yes, it should be pushed, but this should be pushed as a demand from the developers, because it's the developer and who is the developer who's doing these big projects, small projects. It needs to be pushed from that end. Let's upgrade the code. Let's provide more awareness about the sustainability requirement for these small buildings before the sustainability of the bigger projects, because these are the most commonly built in the country. Second, manufacturers and specifications. Manufacturers start upgrading their specifications whenever we have a compliance to the regulation. If we don't have a regulator, we don't have something forcing them to upgrade their regulation or upgrade their specifications, or telling them that you have two supply chain, you have the high end and then you have the medium end and then you have the low end kind of a project. So from the codes and standards, the manufacturers will start doing a different supply chains, maybe 3 or 2 supply chain level. And the third one is the awareness of the community. It's the awareness of the properties, it's the awareness of the engineers, the clients, and the users themselves. It's not only, the users they don't need to be engineers, they don't need to be people who are aware about sustainability and engineering solutions. They just need to be people who are aware that when you are building your house, you have to be, they will ask, oh, but is it compliant with the codes or not? Yes, it is. What is the code telling you? And then from the codes and from the regulation, this will be forced and this will be applied eventually. We face it with residential buildings. Whenever the project is residential and not commercial or any other type of the building, yes, we see that the specifications start decreasing a bit on the material, and this falls into the value engineering. But again, we go back to the point that value engineering is not only about cutting cost, it's about adding value actually on the long term to this building structure. So yeah, I believe this can be tackled that way.
Thank you, all speaker. Allah يحفظكم.
Thank you very much.
Thank you.
Any more question? Any more comments? We good? I think we started with regulations, we ended with regulations,
Yes,
I think.
most important.
Yes.
Thank you very much to our panelists and moderator. Thank you. Guys, I just want to tell you that this whole conference will be on YouTube. We'll send the link in about a week or two. So all of this has been recorded for you to rewatch. Also, I want to tell you that we have tea and coffee outside. This will be the end of the conference. Thank you very much. Thank you to everyone for coming and for sticking.
I think we have one more question there.
There is one point, please. One more question? Last question.
Last question.
We were speaking about local content. Local content, not only about the regulation, also about material manufacturing. Here we have the industry here, we have a lot of industry which they produce a lot of material related to all the construction industries. But the problem now with the consulting, when they put the specification, they put it with a name, with a manufacturing who has already, let's say, supplying this material years and years. I think the points we need to develop with the local industries, the specification which can respond to this demand.
Yes, I can take this one as well. So we face it also in a couple of projects. So again, whenever we are specifying, usually, typically, we have to put a general specification that complies with the international standards whenever it comes to specific facade elements and whenever it comes to the local compliance as well. Sliding in suppliers' names and specific specifications within our documents typically comes from two approaches. One approach is that the facade consultant is strictly working with certain suppliers because they trust their supply chain, they trust their manufacturing, and they know that they can deliver the project and they can achieve an effective project execution. Or it comes from the end client itself. A lot of end clients come to us as facade consultants and tell us, we have a certain list and we want you to specify based on this certain list of manufacturers. So it comes in both ways, but in general, as a best practice, I believe that specification documents needs to be developed with an open source for manufacturer. Any qualified manufacturer who can fit in to what the facade consultant and the client is asking, he's welcome to be on board. So
I think this point responds to my colleague when we speak about the cost. We're going with a local manufacturing. I think the cost will be different also. So I think like this we can approach the small and the big projects with effective cost.
Yes. So the cost is again related to the specification requirement and the quality that you are asking for.
Sure. We will not compromise the quality. We are speaking with the same quality, but at least with the local content.
Yes, so this is again talking about the material supply chain. Are we specifying material supply chain from a global perspective? Are we forcing to import certain material? Or are we promoting to use the local material that is available in the market? And I believe that it's also a direction from different entities in the kingdom that let's promote the local use of this material. If you don't have this material locally, let's look into how to innovate it, or let's look into how to develop this material based on one imported material and start implementing it in not only one project but into other projects. And this is why you can see that the suppliers that we have at the moment, they actually created new chains of products specifically to supply the Saudi market because of the high demand and design, because of the high demand and the specifications. We want to stay away from the global supply chain. It has its own complexity when it comes to regulations and compliance and sustainability requirement when it comes to the CO2 emission, a lot of other complexities. So, or you have the other way. Let's produce locally and use whatever is produced in our countries.
Thank you so much, Hira.
Thank you.
We will end it here. Thank you so much, everyone. Thank you to our panelists for this beautiful discussion. Thank you to our audience for participating. Once again, guys, this is the end of the conference. The link to the whole recording will be available in a week. And please, you can proceed for tea and coffee outside for some post-event networking. Thank you so much, everyone.